First of all, I would like to thank HRDC Nagpur for inviting me for this session. And as I know that this is the first lecture of the refresher course, and it's like there are lots of expectation from the opening batsman. And definitely, I assure you that at the end of the session, you will definitely feel that it was very useful, and that is my assurance. And definitely, I'm going to discuss lots of things related to AI, ML, and deep learning, and number of use cases of those technologies. So, first of all, I would like to start with my presentation. I will share that, and by the time I will discuss all these things. And I hope all of you are having some sort of background in terms of what is AI, ML, and DL. But I will try to cover in that way that it will be applicable to everyone. I mean to say anyone from computer science side or electronic side or maybe non-technical side also, they will find definitely it useful. And I assure that definitely you will also be happy to start working on some of the AI related projects too. So let me start with the presentation first, and then we'll go one by one with the slides. So is it visible to all of you?
Yes, sir, it is visible.
Yeah. So I have changed the title a little bit, like it's machine learning for edge computing. Yeah, I have started directly with some sort of specific topic, but it's not going to be the start. Like directly, I'm not going to jump on the edge computing and all these technical jargons of AI, ML, and DL. But all of you are well aware of Amazon Alexa devices, okay? Right? You ask something and it brings you based on the machine learning and it gives you whatever you're asking to them. So this is one of the recent trends in terms of AI and ML, where people are targeting electronic devices and trying to make and implement the AI into those embedded systems. But how all this started, what are the technologies behind that, and how we can integrate number of different areas into this. First of all, I will start with some fundamentals of AI. Like as everybody says that artificial intelligence is a new branch. It's not a new branch. It is basically all mathematics, which has been like transformed into different latest computer libraries. And because of there is a lots of technological development in terms of computer libraries or maybe software libraries, I should say, and development of electronic devices, development of computing, high power computing chips, development of cloud platforms, and all these technologies has actually boomed it up like anything. And that is why today everybody is talking about AI. If you look at the UNESCO, if you look at WHO, if you look at United Nations, ITU, you look any of the field, like even Standard Chartered Bank or Bank of America, everybody is talking about AI or maybe implementing machine learning into those areas or maybe data science related part into those technologies. So the thing is like, see, everybody has started like moving towards this thing. What is the reason behind that? Because it is going to be the future, and that is why like there are not number of terms that AI is going to be the next fuel, or AI is going to be the next electricity, data is going to be the next commodity, and all these are the things which we are looking for and maybe hearing in our day-to-day life. So what I have started with that, like I will start with a very basic concept of machine learning into the embedded system. Now everybody knows that what is embedded system. Embedded system is nothing but a kind of an electronic development system where you write the programs onto the chip and it is an application specific device. Say for example, when we pay using ATM card or debit card or maybe credit card on a petrol pump, we see that there is a small handheld device that is nothing but a kind of an embedded system where a specific application is running as per the requirement of the petrol pump. Secondly, when we go and use Amazon Alexa device, it is a embedded device. But all these devices are having some sort of intelligence. The human race is basically to transform human intelligence into the computers. That is what the main fundamental logic behind implementing or developing artificial intelligence. What we want to do as a human is that we want to transform all our intelligence to the machines. That is what the race is all about. Now, the thing is, whenever we are talking about artificial intelligence, what happens exactly is that it is all basically dependent upon the data or the data. It's not related to database. Database is a kind of a tabular format. You have some numbers and we play with those queries and finally we get some result out of that. That is a different thing. When you talk about the data set can be audio, video, image, sound, or maybe a kind of numbers or maybe combination of all these. So these are basically data sets, and these data sets becomes the information. So let me tell you how AI is going to change the world. The first thing, look at an example of an orthopedic surgeon who is a very well experienced doctor having 35 years of experience. in doing lots of surgeries and looking at lots of x-rays, and he's like expert of orthopedic area. Now, if you want to replace the doctor, what can we do? Or how we can make an AI system which can be far, far intelligent than a doctor having 30 years of experience. So just take an example to understand the difference, that how AI can make a difference is that, like say in a doctor's life, maybe if a doctor is very busy, he's having lots of patient every day, he's having lots of interaction with the patients and x-rays and operation and something like that. So in 365 days of that particular doctor's life, means in 1 year, maybe every day is looking at 300 x-rays. So 300 into 365. So these are the x-rays which he is having an experience in a year. So if you multiply it by 30, you can come to some number. But when you are making an AI system, you are providing crores of x-rays as a data set, which is having all variety, all sort of data. Because it happens that like in our day-to-day life, maybe like the doctor near to our home or maybe our office or college it's an orthopedic doctor. He may be having a limited source of patients in terms of some specific type, like there is a bone fracture or maybe there is a leg fracture or something like that. But when you are preparing an AI system to act like an orthopedic doctor, is that you are providing all sort of varieties of data. There is a fracture of maybe rib, or maybe there is a neck ligaments or something like that. So the thing is, whenever you are preparing a data set for artificial intelligence, you are having a huge data set. So a human may not having that opportunity to learn that sort of information in that even in 30 years of life, you are providing more than that to the artificial intelligence system, and because of that the system becomes so much powerful. It is able to take the decision far better than a human being. Definitely human preparing those AI systems, but we are providing huge amount of data. I would also give you an example that like we consider ourselves as an intelligent animal on the earth, but we are not that much of intelligent. Just to give you an example, say for example, like if someone comes to our office or maybe as a student or as an employee or maybe in our society, if someone comes from like northeast, okay, or maybe someone comes from like Nepal, or maybe someone comes from Himachal or Tibet, etc. But in our mindset, like if we are not knowing about the exact location of that person, that from which area he is coming, we cannot categorize them that okay, this person is from this country or this place or something like that. But we put them all of them in a common category. When someone comes from the Africa to India, we consider them as African, but we cannot identify that he is a Nigerian, he is a Chad citizen, or maybe he is from Uganda or he is from South Africa, etc. But we are not that much capable. But if we stay for 6 months into all these countries, like same way you look at the example that if you stay for 6 months in China, if you stay for 6 months in Korea, Thailand, Singapore, Malaysia, and all these countries, and now if someone comes from that country to India, and you definitely can identify that okay, he's not a Chinese, he is basically a Malaysian, or maybe he's a Filipino. So like when we learn something, our intelligence increases, and that is why we want to create an AI system by providing more number of data, and we want to make them more powerful and more accurate, as better, even far better than the human, I should say. Okay. So like what are the different developments have been happening to all these technologies, that now when it started with statistics and probability and linear algebra and all these mathematical part. But at that time, there were not so much rich computer libraries were available that people were able to use this mathematics into identifying something. But now, as like companies like Nvidia, Intel, or maybe Google, Amazon, and all these companies have started working on that, there are lots of technologies available basically based on this mathematics, and nowadays we are able to use them directly. I will today like try to show you online example also, that how easy is now like to make an AI application without coding. Even you can create a model and you can even deploy, you can make a mobile application, you can deploy it on a hardware also. So everything is possible even without knowing how to code them. So the technology is improving and enhancing like anything. Coming to this slide, like what are the different, what is the exactly in terms of development in terms of embedded ML, sorry. So machine learning, I will come to that topic later on, maybe after 2, 3 slides. But machine learning is a part of AI where we try to teach machines. Machines are like electronic hardware, or maybe a computer, or maybe any other device. So that is basically where you can write the program, you can feed the data, you can take the output. That is what the electronic or embedded system is all about, where you are providing a algorithm or maybe a model, which is simply a kind of an intelligent model. You load it into the device and finally it will give you the result like with some sort of calculation, which like as a human is all about in terms of intelligence. So recent advances in microprocessor architecture and algorithm design have made it possible to run sophisticated machine learning workloads on even the smallest of microcontrollers. In our second session, I would like to demonstrate a very small hardware like Arduino Nano. Everybody knows that Arduino Nano is a very popular open source hardware platform on which you can make number of applications, and you can create IoT systems, you can create XYZ applications on that. So how you can make that device as an intelligent one? Even you can load a AI model into such Arduino Nano also in header file. So this is the power of machine learning right now, that it is becoming or transforming from computers to the hardware or electronics or maybe the chips. Embedded machine learning, like also known as tiny machine learning, the field of machine learning when applied to embedded system such as this is basically known as tiny machine learning. So everybody is talking, even the Google has actually started this concept of tiny machine learning, that instead of writing the programs, instead of writing the algorithms on the computers, it is better to write it for electronic hardware. Say for example, I want to make an electronic nose. So like as we human smell something, it's a lavender smell, or maybe it's a fragrance, or something like flower smell, or maybe it's a odor or something like that. If you want to make an electronic noise, is it possible to do? Yes, it is possible to make something like that. You provide all these information in terms of fragrance and smell or maybe odor as a data set, and you create an AI model, and that device will be able to identify that which smell is all about. Say for example, you want to create a very small handheld electronic hardware, and you want to put it somewhere in a restaurant, and you want to identify whether it is the smell of a pav bhaji or maybe vada pav or something like that. It will be able to identify, because we are creating that sort of system using machine learning, and that is specifically tiny machine learning. I mean to say, tiny machine learning is basically a very small electronic hardware running a very lightweight AI model. Usually what happens when we talk about artificial intelligence in computer, we create some sort of AI models. So model is basically a mathematical calculation which we do after training all the data, providing it to the algorithm and getting some output. So that is a very large in terms of memory. I should say 150 MB or 200 MB or something like that. But when it comes to embedded system, it is something like in terms of kilobytes. So that is what the difference is right now in terms of normal machine learning and a tiny machine learning. So when we talk about any of the artificial intelligence on the embedded system, a very well-known term by Jeff Beer, he has given a concept of blur, that you need to think of all these parameters whenever you are trying to design a machine learning or an AI system for any electronic hardware. You should look for all these five parameters. The first and very important thing is bandwidth. Bandwidth is, I mean to say, like how much data it can handle altogether. Latency. Latency is all about like when you provide some input, in how much time it responds. Say, for example, if you are writing on a smart board and if you are writing Y, when you finish writing Y and if it displays later on something, it is basically a latent system. It is not giving you a proper output. Whenever you are providing an input, you should get the output. So there is something like a delay in a different language of communication, but latency is basically how fast the system is responding. See, whenever we look something, our brain process quickly and we get the information in that sense. If there is a latency, what will happen? That you look at someone and if you are not able to recall the name of that person, it means that the system has been now latent in our brain. We are old age kind of a thing. So whenever you're talking about an embedded system running a machine learning on that, it should have some sort of fast system, responsive system. So latency is very important thing we need to keep in mind while designing and development of that sort of system. Economics is also very important, that every system in the world should be economic one. So it should not be that much costly. If today someone wants to make a autonomous vehicle, and if that autonomous vehicle is using very costly computers, GPU and cloud platforms and hardware and all those things, and if the cost of that AI system is more than the actual cost of the car, then it's not an economic system. But if you use some sort of electronic hardware, it's something like few dollars, 10, $20 of development board and few sensors. If it will work, the system is basically an economic system. reliability is always a part whenever we are making any sort of computer application or maybe any electronic device or electronic hardware we are working with. It should be reliable one, that whenever you are expecting the output from that, it should give you with a reliability. And privacy is always a case. That is why the Amazon Alexa and Google Home, that sort of device has been developed, because we wanted to see that whenever you are transferring some data in terms of like from your original sound or a voice to that device, if it everything goes to the cloud server of Amazon or maybe Google, then it's not a privacy. Everything should be processed inside the hardware in your home only. There should not be a kind of a transferring of data from your device to the cloud. And that is why the concept of privacy is also there in case of machine learning or any AI system. Now, why we call it as a physical computing? Because like edge computing is also a concept. Like whenever we are talking about any of the AI device where the model is running locally, and if you even still not able to understand what exactly the meaning of edge is, that edge computing is nothing but just try to compare a computer system which is having an AI system running into that. You have written a very well AI model and code into that, and you are providing a kind of an object detection. Say, for example, recently you might have seen that like people use face recognition for getting the attendance, or maybe they want to identify the person or the car from the CCTV camera, or maybe the traffic surveillance camera. So everything is being transferred from that computer to the cloud, and from that cloud, the processing is done and information comes back to the system. So this is what normal AI system. But when we talk about edge computing, the model is already running in the hardware itself. Nothing is transferred to the cloud. Everything, every processing, every calculation is done locally. I mean to say locally to that device. And whenever something is required, then and then the cloud support is taken. That is what the basic difference between a normal AI system and edge computing device. So physical computing is basically the future right now. Every company is working on that. And that is why we have taken this topic. Like we want to focus on edge computing specifically, looking at the AI, ML, and DL concept. The technology remains same, but the platform on which we are targeting is a little bit different, and that is what the normal microcontrollers. So let us see like what are the things into this edge computing or the physical computing. Machine learning models are getting smaller due to development in advanced libraries. See, the library, if you look at the source of library, open source libraries for Python, like there are lots of libraries called NumPy, SciPy, scikit-learn, matplotlib, and number of libraries for machine learning. So all these libraries are being developed based on the open source concept. People are contributing to them. People are trying to make them faster and faster. Even companies like Google are also developing the libraries for like TensorFlow and number of machine learning libraries. Even Amazon is also developing this sort of libraries. So everybody is working on this sort of advanced libraries. So you need not have to write a big program for that. As what we have observed in our C programming language is that whenever we want to use math function, sorry, sine or cosine function into the math library, we have already available a math.h library. So we include that math.h into C program, and we use those functions into the program. We do not write a complete code for the function called sine or cosine. So similarly, we have in machine learning, we have lots of libraries available, but there is no need to write the complete code for that. Simply use those functions and objects available in the library and use them. So these models are basically improving and becoming smaller and smaller is just because of the development of the machine learning libraries. What are the target hardware? So the biggest, very popular and like widely used target is the Arduino system. Arduino, as all of you know, that it's an open source hardware for electronic development, or it's a development board. There are lots of variants available, but the latest one, which is known as an Arduino Nano BLE33 Sense, is one of the latest hardware by Arduino community, and that is basically capable of running a machine learning model on that. Older Arduinos like Uno or maybe Mega will not support this sort of things. But yes, ESP32 is also there. You can run a machine learning model on the ESP32 with a camera, or maybe you can make a very smart object detector device having a 500 rupees of cost only. That is one of the area. Raspberry Pi, all of you know that it's an open source, again, a platform, a kind of a mini computer where you have an opportunity to have a complete operating system on that. And this operating system is again a kind of a Linux base, and that is why you are able to run Python programs on that. And that is why Raspberry Pi is also one of the popular platform. Google has also developed Google Coral Development Board, and that is again a kind of a having a TPU kind of a concept into that. We will see what is the difference between TPU and GPU in our next slides. Machine learning is moving rapidly towards edge devices. As I told you, like Alexa and Google Assistant are the devices where people are contributing into that. And recently, you might have observed that now Amazon Alexa and Google Assistant have provided you also that you can create your own skills. Say, for example, like in Gujarat right now, admissions are going on for engineering colleges, and somebody says that let me create an Amazon Alexa skill for getting the best college or the branch or maybe as per my choice. So you can create a kind of an Amazon Alexa skill, deploy it onto the Amazon Alexa device and ask any question you want. Amazon Alexa will reply you that this is going to be the best source or maybe this is going to be the best branch and college for you. So you need to write those skills for them, and that is why it is becoming more and more customizable. Even it also supports different languages also, because there are lots of different language libraries and engines are available into that. So that is why it responds you in Hindi or maybe Gujarati or maybe Marathi, and all these different voice engines are available. Artificial intelligence on microcontroller enables cheaper, lower power and smaller edge devices. Now, this is one of the most important factor whenever we are talking about any edge computing device or maybe an AI system. Usually what happens that we look at the computers, and most of the time everybody uses computers for artificial intelligence. But move computer, you cannot put the computer in all the application or the use cases, and that is why it comes to the cost, the size, the form factor, the power consumption, and the I mean to say the communication capabilities, and everything should be included into that. And nowadays, like companies like PyCom is making a MicroPython based development boards. So they claim that if you want to make an IoT system or maybe you want to run an AI model on that, the battery will last for 10 years. A single button cell battery will last for 10 years. That is what the power of low power consumption, I mean to say, for the smaller age devices, because it consumes very less power just because of the concept. In the first slide, we had seen that BLERP, and the first one was bandwidth, the latency, and all these concepts were there. So the all the devices are very low. I mean to say, if you want to put a temperature sensor on an Arduino, and if you keep the breathing rate very small, because in India the temperature is not going to change drastically in a day. Say for example, if you are measuring the temperature at 12 at 12:30 or maybe at 12 and 1 p.m., 2 p.m., 3 p.m., it's not going to change much more. It's not a mission critical device, and that's why the breathing rate can be kept smaller, or maybe there is no need to sense continuously, and that is why it will save your power. That is what the main concept behind the low power or low power devices, I mean to say. It reduces latency, conserves bandwidth, improve privacy, and enables smarter application. That is what already we have discussed into this. Now, like how to kickstart. Say, for example, as a faculty or maybe as a student or maybe as a researcher, if you want to start working on some sort of machine learning edge computing device, it's not a rocket science. It's not different. Anybody can having a basic experience of any programming language or a basic knowledge of any Arduino device definitely can start working directly on that. And this is one of the board, like in a blue PCB, you'll be able to see that that is Arduino Nano BLE33. It is rich with number of sensors, so there is no need to integrate any sensors with them, and you can directly use and write the programs on them. And we will also see how to do those things in the maybe today or in the next session. So what do you need exactly? You need a very good computer, I mean to say, having at least 4 GB of RAM or maybe a higher end processor and an Arduino board, and that's all you need. Nothing more is required, because you want to make a AI enabled application or an edge computing device. This is what the basic ingredients for starting with. What are the softwares you require? You need any sort of IDE for writing the code, like Visual Studio or maybe Atom or any available IDE, integrated development environment, to write the software, to write the code. If you do not have all this, you can directly use the Google Colab facility. Google has already provided you the cloud platform by which you are able to write the code on the Jupyter notebook on the Google Cloud, and there is no need of any installation of the library. Even there is no need to install any AI related or machine related libraries into your computer. Everything will be installed in the Google Cloud. The only requirement is that you need a Gmail account. If you have the Gmail account, you will be definitely be getting the Google Colab free with your Gmail account, because to log in into the Google Colab, you need a Gmail ID. And the only thing is that Gmail does not allow you, like Google Colab does not allow you to store the data permanently for a longer time. You can definitely keep them into your Google Drive. Whenever you require to train your model, you can take all this data from the Google Drive. But finally, whenever you log off from the Google Colab, it will finally flush all those things, because otherwise it's again related to the storage constraints and everything. So in today's session, what is outlined for to cover? So initially, I will talk about some fundamentals of machine learning, introduction to the machine learning. Then we'll talk about the transfer learning and classification, how to run a model like TensorFlow Lite or TensorFlow.js or ML5 machine learning for JavaScripts, how to train a model. After running the model, how to train a model. I should say first train and then run. Example like gesture detection with TensorFlow Lite, face and hand tracking with TensorFlow Lite or JavaScript library, or maybe the sensor data classification. I will try to demonstrate at least one of the example out of this. So what we will learn today, what is possible with microcontrollers in machine learning. So it's exclusively making or like making them enabled or meeting them in terms of how you can transform directly the machine learning concepts onto the microcontrollers. We have bypassed the computers right now, but definitely we need a computer to do all this coding and to transfer the code onto the hardware itself. But final outcome or the final product would be an embedded system which is running, having a microcontroller which is running an AI model or a machine learning model, and it is a kind of an intelligent device, I should say. It's a smart device finally. And how you can build or modify some practical examples in terms of speech, gesture detection, image, pose, sensor data classification, train your own models. A few years ago, I had guided one of the PG student for identification of the language. So our main concept was in terms of this speech area, that we wanted to see that like whether a Raspberry Pi is able to classify the language in terms of the type of the language. So like our main target was to classify the language if someone is speaking Marathi, or if somebody is speaking Gujarati, or maybe somebody is speaking English or Telugu or Tamil. Just by looking or just by listening those sounds or maybe the speech signals, the Raspberry Pi should be able to identify the person speaking is Marathi or maybe in the Marathi language, or the person speaking is in Telugu language, etc. So we started with collecting all the data sets. Usually in Indian scenario, what happens when we are talking about AI or machine learning related development, we do not much focus on the preparation of the data set. This is one of the biggest mistakes actually we are making. Why? Because if you look at the US universities, they spend 1 year of time for preparing the data sets. Like while in India, usually in terms of like at the graduation level or at the PG level, what we do is that we directly download the data sets available from kaggle.com or any other university websites. But when the data sets are prepared, they are always biased, they are not universal, they are having geographical biases also, and that is why it may be useful for learning purpose, it's fine, but it may not give you the exact results. Just to give you an example, like everybody of us like use Google Maps. When we try to find out some location, we use Google Map. For getting the direction while driving in a car, we use Google Maps. So we enter the destination and we find the route, and it speaks about like you turn left and right, and on the map itself it shows you sometimes the traffic condition also. So there is a red sign, or maybe a particular portion of the road is basically red. It means that there is a huge traffic available over there. It is going to take some time. On which particular basis you are having this sort of traffic alerts? Just because it is basically a kind of a crowdsourced information that everybody is using Gmail account, and because of the Gmail account, the based on the location, actually Google tracks the Gmail users. And if the density of those Gmail users are higher into that particular area or the traffic signal, it shows you that there is a huge traffic or heavy traffic here, and that is why it will show you a red line over there. But what about cows and buffaloes on our Indian roads? They don't have Gmail accounts. And that's why it's not possible to identify exactly with an accuracy that, okay, this is going to be the traffic condition. Many a times it happens that on the road, even there are no other person traveling, but even though there is a blockage of the traffic just because of the animals on the road, or maybe on the city, we have different types of conditions of the road, and that is why it's going to create a traffic condition over there. And that is why that model of Google Maps is basically not an accurate one. It simply looks at the density of the Gmail users over that particular area. So speech is one of the area where we actually started with downloading the data of languages. Now, biggest problem in case of speech signal is that whenever we record some speech, it always has a kind of a noise included into that. Say, for example, if I right now record some Gujarati's speech and I want to use that for my machine learning project, then maybe surrounding areas, maybe there is a noise of traffic, or maybe there is a noise of some students, or maybe a fan, or maybe any electronic devices, or maybe machinery, something like that. It cannot be a noise-free speech. That is why the biggest target or biggest problem or biggest challenge with us that we wanted to have a clear-cut sound of all these different languages. So we went to YouTube and we found that on YouTube there are different channels of Doordarshan news, DD Marathi, DD Odia, DD Gujarati, DD Hindi, DD Punjabi, etc. So whenever a news reader is reading the news, it's always a kind of a noise free. And we downloaded all the audio clips from them, and when we label them with different, and then we segment them with 10-second, 20-second kind of speech signals and audio clips, then we train them using that, and we deploy finally an AI model on the Raspberry Pi, and connecting a microphone on that, we were able to successfully test having more than 85% of accuracy that whenever you speak Marathi, whenever you speak Tamil or Gujarati or Hindi, it was able to identify the language of the person. So that was a kind of a just an approach that how we can implement a kind of a speech related machine learning model onto that. Second one is the gesture detection. Gesture is a very important aspects in our day-to-day life. The biggest application of gesture is basically in terms of sign languages, or maybe the person having speech and hearing disability. Gesture is always very useful. You can create text, you can create sentences using your gestures, and gestures are very important. But gestures are also very important in terms of our day-to-day activities also. Many of you might be wearing an Apple Watch or maybe a Samsung Gear, which is an AI-enabled watch. And basically, whenever you start walking or start cycling, or maybe you are sleeping, the watch actually identifies your gesture because it's an AI-enabled. All the sensors data have been trained, and based on the training algorithm which is running inside the watch gives you the exact gesture of your particular physical activity. And that is why gesture is also one of the important aspects. Even you can have lots of application in terms of fall detection. Like in US there are lots of elderly people where when they are alone they sometimes fall down into their house, and just finding out that sort of gesture, or maybe the accelerometer data from those wristband which they are wearing, it's enabled, and it immediately informs the 911, and finally you get the help, or maybe in case of emergency you get the support. Image and pose estimation, like recently somebody has developed a very good application in case of AI having the pose detection, that if you are doing some yoga, whether you are doing a proper yoga and the pose is proper or not, the AI system will tell you that whether you are doing the right posture or not. Sensor data classification is again very important area where you have lots of sensor data available, and it is said that like by 2030 zillions and trillions of data will be available from different sensors, and to store them, to manage them, to do analysis, to do some sort of to get the useful and valuable information out from these sensor data will be a crucial task, and there will be a huge demand of data scientists and data analyst people specifically for sensor data classification. So these are the areas where we can definitely work. So in today's session, what these are the three different things I'm going to show you: how to run training from scratch to create a model, what common errors you might encounter and how to handle them, how to customize the model by training it with your own data sets. This is one of the interesting book, those who want to start with tiny machine learning. I should say it was a privilege for me to have an interaction with Pete Warden, who is basically from Google, and he has written this book. So it's very costly book, but he had given me a kind of a specimen copy in terms of PDF file. So he told me that if you want to share with your faculty members, definitely you can, because this is the only book available right now if you want to use machine learning on a very small microcontroller board. So maybe after a session, I will share with the madam. So let us start with the machine learning concepts first. Coming to this, because I've already created some sort of background, but now coming to the main topic, like what is artificial intelligence, machine learning, and deep learning. All these three terms are interchangeably used by different people and different technologies. But AI is in general, it's a very broader term. Machine learning, I should say, it's a subset of AI, and deep learning is again a subset of machine learning. Machine learning. And this is a very popular image by NVIDIA. Usually you will find these in most of the AI related presentations or talks or sessions or lectures. This is a kind of a image which is basically available on the NVIDIA site, which shows that AI is a wider area, like broad category. It started in 1950s actually. It's not a new concept. Early artificial intelligence steers excitement because at that time people were only talking about mathematical part of the AI. There were not much computer libraries were developed. But later on, like machine learning begins to flourish because of the development in terms of chips, processing power, computing storage facility, and computer libraries, or I should say computer program libraries or APIs. That started in almost later 1980s, and in 2000 it was more very well advanced. I mean to say, after 2010, there was a entry of the deep learning that was specifically for image classification, image related data. Then later on, people started working on the audio related data. Just hold on for a while. 2:30 after 2:30. So the deep learning is again a very popular concept which we are using today, specifically for image classification, maybe data related to visuals, and that is what the computer vision is. The concept is all about. Even the audio can be converted into images, and then even we can process them as per our requirement. So AI is the science of making things smart and intelligent. That is what a very fundamental concept of artificial intelligence. We want to make everything smarter. Human race is that we as a human don't want to do anything. Machine should work like us, and we want to sit leisurely. We don't want to do anything. That is why we have invented remote controls. That we don't want to go somewhere. We want to just press the button and it should work. But nowadays, we even don't want to think something. Somebody has posted a message. Let me check that. Not able to see that chat message. Is my presentation visible to all of you?
Yes, sir.
Yes, sir.
Okay.
Yes, sir. Yes, sir.
Yes, sir, it is visible.
Participants in between, you can interact with sir also.
Yeah, please.
सो गए सब लोग.
Yes.
How audio can be converted to image?
Yes, ma'am.
Can you
Yes, ma'am.
Can you repeat, sir?
Hello.
Yes.
Yes.
We can convert audio to image.
Yes, audio converted into that is known as a spectrogram. So like recently, I will let me discuss right now. Recently, what we did is we were working on mosquito wing beats sounds. So like mosquito is one of the deadliest animal in the world after human. So like the first is the mosquito, second is human, considered as the deadliest animal on this earth. And like even as compared to corona, the deaths have come, the numbers have come actually. The deaths because of the mosquito is very huge. Every year, like billions of people die because of the mosquitoes, and there are various types of mosquitoes. So we started working on some sort of identification of different types of mosquitoes, and what we did is we actually tried to identify the wing beat sounds. So we actually, as I told you, that we do not have that sort of facility. We do not have that sort of facility to record the mosquito wing beat sound. मतलब जो मच्छर की गुनगुनाहट जो बोलते हैं ना हम लोग, like कान पे जब मच्छर आता है तब मालूम चलता है like there is a mosquito near to us. So the thing was like that we wanted that sort of sound data basically. So there is one agency in the world, there is a research organization in Spain. They have collected a huge amount of data for mosquito wing beat sounds, and like there are mainly three types of mosquitoes in the world, like Culex and Anopheles and Aedes aegypti. These are the three deadliest mosquito in the world, and WHO said that if you have this sort of mosquito around you, you want to have some sort of disease like chikungunya, malaria, and number of things related to they call it as a vector-borne diseases. So we actually collected those data of something around 14 GB of mosquitoes' wing beat sounds. Then we tried to classify them using the different machine learning algorithms. We deployed them on an Arduino Nano, and finally it's all working now. If you bring any mosquito close to that electronic chip, it will identify with the name of that mosquito, because all these three different mosquitoes have different sounds of wing beats. मतलब जो उसकी जो पंख जो रहती है उसकी जो the frequency of that those wing beats is different, and because of that the sound generated by them is also different. And that is why what we did actually, the sir has rightly mentioned that whenever you have an audio, you convert them into a kind of an image. So we actually converted all these audio clips of 1 second to image. We created spectrograms, and based on the spectrogram, all the images were classified with some sort of labels like Aedes aegypti or maybe Culex or Anopheles, something like that. And it has got, we have got around 87% of accuracy, by which we are able to classify them very well. And nowadays it has been submitted to some, the paper has been submitted to some conference of International Communication Union also. So we are waiting for the result, and that is what like I wanted to discuss here, that the sound, whenever you come to the sound, you need to convert them into a image, and it is basically a spectrogram. And there are lots of libraries available in Python by which you can convert any audio into a spectrogram or maybe an image. So there is a ready-made library available by which you can convert any of the audio into that. So coming back to the slide, it is not the subject of computer science, IT, electronics, or mathematics. It is a subject of all. That is what I always say to everyone, that it's not anyone's subject, it's everyone's subject. Even you look at the business intelligence, those people who go for Master of Business Administration in like very good schools, like London Economic School or maybe Sloan School of Management at MIT, they teach all these mathematics, computer science, and everything to the MBA also, because it is the subject of all and everybody needs that for business intelligence also. And that is why the base is basically mathematics. So if you want to say the root is mathematics, then there is a development in terms of computer science. Human intelligence exhibited by machine is what is all about the artificial intelligence, a broad term for getting computers to perform human tasks. And the best example is the Boston Dynamics robots. Many of you might have seen those videos on the YouTube that like Boston Dynamics has developed robots like human. If you train them like anything, they will work like humans only. Like if you do continuously some repetitive tasks to any of the robots, they will reply you like human. Just I always tell my students that whenever you ask Google Assistant some questions, that ask Google Assistant like, hello Google, how are you? So it will reply with a normal response that I'm fine, how do you do, something like that. Again, ask it again and again, again and again. Then see the difference of answers you are getting from Google Assistant. So the thing is, like, if you ask a human similar type of questions again and again, the human will respond in a different way. Finally, it will also tell you that whether are you okay or not, something like that. So it means that like devices are also capable of thinking like humans, and that is what the power of AI, and it is all prepared and trained by humans only, and that is why there is no magic or maybe logic behind that it's not going to work. And what is machine learning is basically it is one of the approach to achieve the artificial intelligence by which we are actually use or term the word as a machine learning, a field of computer science that uses statistical techniques to give computer system the ability to learn with data without being explicitly programmed, because everything is being done by learning. This is one of the approach that, like, we look at a child. There is a child of say age of 4 to 5 years. So when at this age, usually what we call it, that like in the family member, we try to teach that child, this is mama, papa, dada, etc. So the child will learn, and based on the data or the experience, we are not programming him, but we are actually providing lots of information, lots of data every day, and that is why it gets trained, and finally we have the knowledge. Today why we call someone or we respect someone, because we have been trained like that. We have been trained with some sort of data and information, and that is why we behave like this. So that is what sometimes we call any of the student or maybe any of the person above age 18 is not responding well to some sort of situations, or if not behaving well, it means that sometimes we call that उसका मतलब इनके क्या बोलते हैं, कल्टीवेशन अच्छा नहीं हुआ है. Why? Because it has not been trained with a very proper data. And that is why the outcome or the trained model in that particular human is not well. And that is why it is responding like that. And you cannot change that completely. You need to train them again and again to improve the model efficiency. That is what the main concept in human being also. Similarly, we try to train the computers and hardwares or electronic chips like this. Machine learning is a technique for using computers to predict things based on the past observation. That is what like we human also understand. Let me give you an example that like if I show this mobile phone and if I ask anyone that what is this, everybody will reply that this is a mobile phone with the highest level of prediction. But if I say this is a black rectangle, that is also right. There is a like black glass or a glass having a rectangular shape, that is also true. If someone says that it is simply a black rectangle, that is also right. Someone says it's a communication device, it is also right. But someone will say that okay, this is a Realme XT phone, that is highest predicted information. So we as a human try to predict as close as possible. We know even the category of that particular object, that it falls under an electronic device, electronic gadget, or a communication device, or maybe something which is clearly visible to you like a glass or a black screen or something like that. But we are so much intelligent that every time whenever we see something we learn, and finally we try to bring out the result as much as close possible to that. Let me give you another example. What happens that we always consider ourselves as that we are the most intelligent animal on this earth. We know almost every fruit in the market. We go like we banana and apple and orange and everything. Recently in Indian market, since last few years, we have seen that there is a dragon fruit has been entered. So when it came for the first time in the market, many of the people were not aware about the name of that fruit. Okay, dragon fruit now it is possible for us to identify and we call. But if you bring any other fruit in the market and put it somewhere, and if somebody asks you question that what is the name of this particular object, then as a human we are that much of intelligent that we can at least categorize that it's a vegetable or maybe it's a fruit, but I don't know the name because we have never seen that. So the only thing is that whatever we have seen in our life can only be predicted or maybe categorized. Similarly, if you show the data to the model into the machine learning process or to the computers, the how much data you have given to the computers can only be predicted. If you keep some bias, if you keep some sort of um, not a higher variety of data, it is not going to work well. And that is what the main concept is all about. What happened in 2019, I actually downloaded one data set for human gesture detection, facial expression detection, I should say exactly. So humans have various facial expression like smile and angry or maybe disgusted or maybe somewhat confused, something like that. So I downloaded the dataset from one of the university website of United States of America, and I looked at the data. So there were 30 objects. Objects means person who contributed for recording those photos. So the objects were from different country of the world, but not a single object or a subject, I should say, not a single subject were from India. लाइक अफ्रीका में से था या यूरोप से थे कुछ लोग, रशिया से थे, यूएस में से थे, लाइक पीपल वेर फ्रॉम दिस ज्योग्राफिकल एरियाज बट नन ऑफ देम वर फ्रॉम इंडिया. Now I downloaded that and I created a mobile app, and when I started using that using my camera, and if I do some sort of gesture, facial expression, it was able to predict. But specifically for angriness, whenever a person becomes angry, the facial expression of human in case of India is different than the normal anger gesture or anger facial expression as other part of the world. हम लोग जब गुस्से होते हैं तो कुछ ज्यादा ही गुस्से होते हैं, like in United States people जब like when they create a facial expression for anger, it's like usually हम disgust होते हैं तभी ऐसा करते हैं, वहां पे वो इसको angriness बोला जाता है. So the thing is like that was not universal data, it was only a kind of a geographical biasing for that. And if you create that sort of application for Indian continent, it may not give you the proper prediction. So my main motive of this discussion is that we need a variety of data. More the data you have, more the truth you have. That is what the fundamental logic behind any of the machine learning application. Okay, now what is the difference between normal programming we use in case of traditional programming versus machine learning programming, or maybe when we do machine learning. In traditional programming, usually computer, we provide some data, we feed the program and we get the output. That is what the normal scenario is all about. But in case of machine learning, we have data, we have already some output. We know that we want to bring out this thing, and that is why we try the computer that create a program. So program is basically a logic, which is basically a model, and what we get as an output of that training, we get a model, and that is what the program we get. So it's a little bit different. The programmer feeds data into a special kind of algorithm and lets the algorithm discover the rules, and finally it will give you the outcome based on how it has been learned. Next is basically the deep learning concept. It is a technique for implementing machine learning, specifically for considering the neural network architecture. Like, we are so intelligent in terms of that we have actually mimicked the human neurons, or maybe the neurons which are firing inside our brain, and there are billions of trillions of neurons firing all the time till we die. And that is why we have tried to replicate that particular thing, and we call it as an artificial neural network. That is what the concept is developed. So similarly, how our neuron works, how a neuron to neuron electrical voltage is transfer, and finally we get some decision, or we are basically taking some sort of inputs and getting the output based on that. The mimic of the human neurons have been developed, and that is what the artificial neural network, and we sometimes call it as a convolution neural network in case of deep learning. It is basically a kind of a representation or the features from the data, such as image, video, or text. Usually what happens in case of human being, when we see something, we never try to remember anything, but our brain actually processes everything through the visual cortex. So visual cortex is the main convolution neural network in our brain, and this visual cortex processes the information. It gets the feature out of that. So we never remember anything. Like, just recall our childhood memories, that when we were in the senior KG or junior KG, or in some of the early years of our education, we had that sort of ABCD: A for apple, B for ball, C for cat, and Z for zebra. Maybe many of us might not have still seen any zebra in the real life, but still, if any zebra comes in front of us, we will identify that this is zebra. Why? Because while learning that Z for zebra, some classification has already been done. Some sort of, I should say, the feature extraction has been done out of that, and we try to recollect everything again and again. And it happens automatically because we have, I should say, unlimited memory to store, unlimited processing power. I had read one of the Google's paper, and they have said that if you want to replicate the similar human brain in terms of computing facility, we need some sort of power. We need some sort of computing centers, and that is maybe like in area wise. If you look at that, you need a complete California's geographical area. You need this much of gigawatts of power. Then and then you can replicate the human brain. So it is so difficult, but like, how cool we can take the decision, we process the information, we have lots of cognitive sense, and we have lots of ability and number of things all together. So it's a very complex part. We are still not able to do anything in terms of replicating the brain. We are not still able to understand the brain waves properly, because how everything happens, it is still a kind of a mystery, and people are still trying to identify and work into those areas. And any of the faculty, those who are like maybe working or interested in working in terms of brain waves or maybe EEG analysis using machine learning, it's one of the trending area these days, because everybody wants to see that, like, how you can predict something, that what thought you might be having after 1 hour or maybe after 2 hours. So they are trying to learn those things. That is one of the area where people are working right now. So this is a kind of a convolution neural network, kind of a deep learning architecture, that we have some input layers and there are some hidden layers in terms of neuron. This is an artificial neural network, and we get some output based on that. So if we see something, we provide the input information, everything is processed, the outcome of the first layer or the neurons is fed to all the second layer of, or the hidden layer of the neurons, and finally we get some sort of predicted output as much as close to the real answer. So just look at this example. It's a very popular image, and I have also shared a YouTube link. If you get the time, try to see this YouTube video. It's a very interesting implementation implementation or the understanding of how we understand the digits. So whenever you start learning AI or ML or DL, you come across this sort of digit classifier, that handwritten digit classifier. However, we write 1 to 0, 9, I should say 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. We are able to identify them. And that is why how a human eye perceives the information, how the visual cortex processes that, and finally how the brain takes the decision. So whenever you look at the 7, even though it is written like 1, but you will be most sure that it is a 7. It is 1, it is 2, it is 3. And like as many as people write 1 to 7 or 1 to 0 or 0 to 9, they all have different styles and strokes of writing them. But as a human, we consider them as very intelligently, and we are always right in predicting the digits. So this was a kind of a similar approach to identify how a human can understand the digits, similarly how a computer can understand the digits. Recently, you might have observed that whenever we are having some sort of security checks on the internet while maybe opening a new email account or maybe logging into the website, you see different captchas over there. And captchas are having some sort of handwritten digits kind of a thing. But nowadays, the AI system can even immediately identify even the captchas also. So even now people have started like stop putting the captchas like handwritten digits. That is what the another concept, that AI technology is improving so fast that even the captchas are to be changed, and that is why sometimes the combination of those captchas or maybe image or sound or something like that. So how we understand, that is a very simple example in this deep learning book.
Hello.
Hello sir.
Where these captures came means how these captures generated and how these identified. Where the conversion take place. Whether
Yeah.
it is also a part of deep learning.
Usually the captchas are like say for example, if you want to put some captchas for security purpose, they are basically kind of some API libraries by which you can put it into your website. So it's a random generation of different hand digits. But if you want to identify, say for example, I want to break that security with the machines. I want to put a web camera in front of my computer and I want to read that captcha. So even the machine learning model will be able to identify the handwritten digits in terms of captchas also. That is what is possible right now. And that is why I told that people have started using the captchas in terms of handwritten digits. So captchas are basically the libraries or maybe the image set or something like that. It's already available as a library, and you can use any of the captcha which is randomly being generated. So whenever you log in into some page or maybe you refresh the page, captcha will change finally. So it's all a human made. It's not a kind of a machine made. But Google is using different logics for that. Like sometimes they give you how many buses are there in the different pictures, and when you select them, it immediately changes with some another images, and they try to see that you are real human, you are not a machine or you are not a robot kind of a thing. So that is what the main logic behind that.
So
So,
one more question.
yes, please, madam.
How to select the number of like in your model you have demonstrated the recognition of 7. So is there has any particular criteria been set to select the
Yeah.
number of neurons
Yes.
per layer?
Okay, so there are different techniques and logic behind that. It all depends on the data, first of all, the variety of the data, the number of data, I mean to say. Say, for example, you do not have much information. I mean to say you do not have much data set, bigger data set. Uh, so at that time, what I need to do is that I can go for some sort of specific layers of the information and in which thing I'm interested. I mean to say, like whether I'm interested in classification, I'm interested in object detection, I'm interested in multiple object detection in a single image. Then based on that, some layers will change. Another thing is that the way I'm preparing my training algorithm, architecture of the algorithm, how I'm designing that. So there are a number of parameters which are known as hyperparameters. So these hyperparameters are basically different methodologies of training a model. Let me give you a practical example of that. If you are teaching a very small kid that what is the different types of pens and pencils. So I might have collected thousand of different pens available in my market and different types of 1000 pencils. Again, those pencils are also different, having a lead or maybe the fresh one, or maybe having a rubber on the back side, and different types of pencils and different types of pens. So what I will do, I will show that kid a different pen, like first pen, then another pencil, another new pen and another new pencil. I will try to show them, and every time I will tell that child that this is pen, this is pencil, and I will show all these 1000 pens and 1000 pencils in front of that child. Now what I will do, I will take some unknown pen and pencil which were not shown to that child, and I will try to ask him what is this. So that child will be able to identify with some accuracy, okay, whether it is pen or a pencil. Now what will happen if my training methodology is different? Then how the child will behave in terms of predicting the right answer for unknown data or unknown pen and pencil which was not shown to them during the training period. So how it is possible? If I show them 200 pens consecutively first, like one pen, second pen, third pen, fourth pen, up to 200, and then I will show one pencil, second pencil, like 200 pencils altogether. So I will have batch of 200 pencils like 5 times and 200 pens for 5 times, so total 1000 pen. Now what will happen if I don't do like that, and if I do something, I will show continuously all the 1000 pens all together, and then later on all the 1000 pencils all together. Or maybe if I show two pens and two pencils, three pens and three pencils, or maybe one by one, etc. So that is what is all about, something like learning rate, in which way I am learning or maybe teaching the model or a child. So similarly, how a child will learn, similarly the model will learn. So sometimes what happens that if we do not have much information or much data, it cannot give you the exact result or with a higher accuracy. And sometimes it happens that the child is also little bit intelligent in terms of memorizing something. So without looking at the type of that thing, but it will try to remember that, okay, ऐसा था तो ये पेन है, ऐसा था तो ये pencil है. That is a kind of a memorization of something. Similar thing what we have observed in case of our kids, when we are teaching our kids, or maybe हम किसी का जब छोटे बच्चे से कुछ क्वेश्चन पूछते हैं कि चलो ये 5 क्वेश्चन प्रिपेयर कर लो, मैं आपको पूछता हूँ, ठीक है. What happens at that time? As a parents, usually we start asking with the fifth question first, or maybe the third question first. Randomly 5 में से हम किसी फर्स्ट क्वेश्चन को ज्यादा पहले पूछते हैं, पहला नहीं पूछते हैं. तो बच्चा क्या बोलेगा हमको? ऐसा नहीं पापा, पहले से मुझे क्वेश्चन पूछो, लाइन में पूछो, ऑर्डर में पूछो. बिकॉज the child has memorized something, and that is why based on the previous data he is able to predict the second data, or maybe he is able to answer that second thing. But when you shuffle the data continuously in terms of hyperparameter tuning, whenever we have a huge data set of all these information, or the images, or maybe the audio sound, or maybe video clips, what we do every time while training the model, we shuffle the data. हम सब डेटा को shuffle कर देते हैं, फिर से कुछ नया देते हैं, कुछ बैच बनाते हैं, लाइक 2020 का बैच बनाते हैं या 100 का बैच बनाते हैं, उसको फिर से रिपीट करते हैं. वी आर डूइंग दैट थिंग अगेन एंड अगेन, सो दैट वी कॉल इट एज एन इपोक काइंड ऑफ अ थिंग. सो लाइक से 500 इपोक्स मींस जो पेन मैंने 1000 टाइम ली थी उसको मैं 5 बार घुमा रहा हूँ. मतलब शोइंग one pen, second pencil, second pen, third, second pencil, third pencil, etc. I will do that sort of 1000 iterations. मैं उसको 5 बार करूंगा या 6 बार करूंगा. So again it will improve, and जब भी iteration होगा, the model will actually shuffle the data, and finally it will become like, कहीं पर भी ऐसा नहीं होगा कि model will memorize something. कभी कभी क्या होता है कि if you have visualized the training really in a, like if you have already worked into this area, and if you have visualized the training portion, what happens exactly after having like 30% of the training itself, the model starts giving you highest accuracy. 90% accuracy आ ही रही है, मतलब अभी तो 30% data को train किया है आपने, it has started giving you 90% of accuracy. What is the reason? Because now the model has started memorizing things, and if the memorizing or maybe the accuracy is very higher in the beginning of the training, it means that वो चलने वाला नहीं है. It's not going to give you the proper output or proper result based on that. So something like that, you need to change those parameters. So madam, as you told that हम कैसे इसका decide करते हैं, so it is something like trial and error kind of a thing. What I have personally observed is that आप एक बार लेयर एक डाल के देखो, उसमें आप 32 लेयर डाल के देखो, 64 करके देखो, 128 करके देखो, उसको चेंज करो, या फिर चेंज द हाइपर पैरामीटर्स, like change the learning rate, even change the shuffling rate of those things, change the epoch, change the iteration, change the batch size also. So आप जब सब पैरामीटर के साथ all together you try to mix and match everything, you will be able to identify that, okay, now my model is performing well or behaving well. कभी कभी क्या होता है कि आपकी validation accuracy या training accuracy में कुछ change आ रहा है, तो इसका मतलब आपका model over fitting हो रहा है या under fitting हो रहा है, it's not properly. designed or properly trained basically. So we need to play with the architecture of the model, and this model will definitely let you know that now it is perfect. But most of the time मैंने जो observe किया है, I'm not a master of all these things, but just to tell you that जब कोई रिसर्च पेपर लिखते हैं, जो भी इसमें काम करते हैं वो एरिया में, वो क्या करते हैं, किसी का एग्जिस्टिंग वर्क देखते हैं कि उसने क्या किया था, कौन सा आर्किटेक्चर लिया था. People try to first of all try to implement that thing, and then they try to modify all these parameters and try to bring a new higher accuracy with the existing things or the existing concept. वो सब क्या करते हैं, they change the hyper parameters, they use different layers, उसमें layer में change करते हैं, कुछ नया add करते हैं, and that is how they try to bring out some new concept. And most of the paper in the initial or early days of machine learning or AI or deep learning were like these only. But now people have started working and contributing with some new concept into that. And the latest one, or maybe like it's, I should not say it is latest one, but how a Google came with a new concept of inception. That is the inception model, or I should say it's something like not the reinforcement, but transfer learning. That is what the main concept of a new model completely. Let me take a few minutes to discuss that also, but otherwise I will forget that. So transfer learning is again a concept of like utilizing the existing knowledge from the model to use for something different. Say for example, in a very simple way, आपको यदि आलू की सब्जी बनाना आता है तो you can make दूसरी सब्जी भी आप बना सकते हो. That is what the main basic skill is all about. If you know how to ride a bicycle, you will be able to ride a bike also. So similarly, Google has developed a kind of a model, Inception model. Inception model was a very big model having billions and trillions of image information, and that took 3 months to train that model. अब वो model market में है, it is free to use. If you use that Inception model, it is able to identify any object of the world. आप उसको कुछ भी दिखाओ कंप्यूटर से, कैमरा से, you show an elephant, you show an umbrella, you show a mosquito, you show a fan, a broomstick, कुछ भी दिखाओ, it will be able to identify because they have covered every object of the earth of this earth. Now what happens? We are not interested in utilizing all these objects, but we want to use it for our own purpose. So हमने एक बार क्या किया कि we downloaded that Inception model, and we wanted to do classification like whether you want to identify whether the gender of the person, like whether it is a male or a female. That is what we wanted to do. So we had an option that we can create our own model, or maybe we can go for the transfer learning concept. So we downloaded the Google Inception model. उसमें जो last layer था उसको हमने सिर्फ मेल फीमेल के पासपोर्ट साइज के फोटोग्राफ से ही ट्रेन किया, and we got a different output for that. Finally, we did not have to work for architecture, design and complete model का जो preparation करना है होता है, we didn't have to do that because it was already done by Google, and Google has already given that concept that use this model for your own purpose to train something. क्योंकि गूगल में ऐसा नहीं था कि इट वाज एबल टू आइडेंटिफाई द जेंडर ऑफ द पर्सन. गूगल इंसेप्शन मॉडल में ऐसा नहीं है कि इट विल आइडेंटिफाई यू द जेंडर ऑफ द पर्सन, मेल और फीमेल. बट वी चेंज द लास्ट लेयर. आप जो बोल रहे हैं कि हम इसमें कैसे चेंज कर सकते हैं, सो वी चेंज द लास्ट लेयर. इन दिस इमेज आप देखो थर्ड हिडन लेयर है, तो उस जगह पे हमने एक लास्ट लेयर में उसको चेंज किया और उसको फीड किया से. Then finally we got that it was able to identify the gender of the person with 90% of the accuracy. But then it was not able to identify, like if you show elephant, it will not show you anything because it has been now retrained. So it was a retraining of the existing model by which you are able to get some output. So ये सब जो है ट्रिक्स है, या आप कुछ भी देखिए, there is no kind of a thumb rule कि आप कितने लेयर्स रखेंगे, कौन सा पैरामीटर कैसे रखेंगे. आप अपने कोड में देखो, कोड में जाकर को चेंज करो, फिर आप देखो ट्रेनिंग का एक्यूरेसी आउटपुट क्या आता है. So based on that, you can play with the parameters and you will improve your accuracy at the model. That main concept is all about. So
Excuse
Miss
me,
Clarissa,
sir. Excuse
yes
me,
please.
sir. Can I conclude from this discussion that the trainee data is not depends not a successful can build the successful model. It's only act as a prototypes.
नहीं ऐसा नहीं है मैडम. There are lots of parameters. First, the data is very important. आपके पास डेटा कितना है. आपने यदि जैसे मैंने बोला कि मेरे पास यदि कम डेटा है तो आई विल नॉट बी एबल टू मेक ए वेरी सक्सेसफुल मॉडल बिकॉज आई डू नॉट हैव मच इन्फॉर्मेशन. वो उस हिसाब से ही मुझे आउटपुट देगा. मतलब जितना मैंने सीखा है, इफ आई हैव बीन ओनली 5th स्टैंडर्ड पास आउट स्टूडेंट और 10th स्टैंडर्ड पास आउट, आई विल हैव दैट मच ऑफ नॉलेज, दैट मच ऑफ इंटेलिजेंस ओनली. उस हिसाब से आपके पास ज्यादा डेटा है तो आप पहले ये श्योर है कि यू आर गोइंग टू हैव अ वेरी गुड मॉडल और एक्यूरेट मॉडल, which will predict most of the time accurately, like 90% or more than 90%. Second thing is, आपके पास डेटा तो सफिशिएंट है, बट आपका मॉडल आर्किटेक्चर जो डिजाइन किया है वो प्रॉपर नहीं है. जैसे मैंने बोला कि आपने कैसे लर्निंग रेट रखा है, उसको आपने कैसे प्रोसेस किया हुआ है इन टर्म्स ऑफ द बैच और मे बी इपोक और इटरेशन, जो भी आप बोलते हैं, वो सब पैरामीटर्स को आपने किस तरह से यूज किया है. आइदर यू हैव यूज्ड एन काइंड ऑफ ए टेम्पलेट काइंड ऑफ ए थिंग, जैसे कि कोई एक मॉडल है केरास का, आपने लिया है, उसमें आपको एक मॉडल दिया हुआ है, आपने एज इट इज यूज किया है, यू गॉट सम 87% ऑफ एक्यूरेसी, दैट्स फाइन. But now it is our duty that we want to improve that model. So what we will do, we will play with the learning rate first. कि learning rate चलो 0.001 था, उसी जगह पे आपने 0.01 कर दिया, मतलब थोड़ा ज्यादा कर दिया, कम कर दिया. See the difference. What is the output? Accuracy आपका 90% हुआ कि 82% हो गया. Then there is no change at all. It means that learning rate is right now not affecting your training. बट नाउ चेंज विद द लाइक आपने उसको रीशफल किया डेटा को. रीशफलिंग आप कब करते हैं, हर बार रीशफलिंग कर रहे हैं या फिर आप कैसे ले रहे हैं उसको, तो उस हिसाब से आप देखिए, तो उस हिसाब से आपको मिलना चाहिए, ये मेरा मानना है. सो इट्स नॉट लाइक दैट यू कैन नॉट डू एनीथिंग विद दोस थिंग्स, लाइक there is not much control. There is a huge control over us because everything is made by us. We are the sole I mean to say developer who are able to play with those parameters and finally bring out those results.
Thank you, sir.
Hello,
हाँ, please.
sir. Sir, in research fraternity, up to how much percentage of accuracy the predictions done by the model can be considered as acceptable?
Yeah. What I have personally observed with like discussion with some sort of my students who are working in industry like say Canon or maybe Facebook, etc. So they have told that usually we start with a very good accuracy. We call it as a, if it is more than 85%. What industry actually looks for, that we cannot bring 99% in any of the case. Maybe you can try with that, but that would be a biased model kind of a thing. But usually 85 से ज्यादा होना चाहिए. जब भी कोई कंपनी किसी वर्क के लिए कोई एमओयू साइन करती है या कोई टाई अप करती है या कोई कॉन्ट्रैक्ट लेती है एआई के लिए, सो एट दैट टाइम व्हाट दे डू, दे इनिशियली सेट अप दैट at least we want 89% of accuracy or 92% of accuracy or 95% of accuracy. So based on that they start working. So initially मैंने ऐसा देखा है कि जितने भी जो पेपर्स है या जो कुछ भी है उसमें 87 to 92%, if you have got that sort of accuracy, it is considered to be good. जब भी आपका कोई 95% से ज्यादा जाता है तो people will question mark, इतना ज्यादा accuracy कैसे आ गया भाई, क्या किया इसने ऐसा. So sometimes it is also, but you need to prove if you are having a very good accuracy, if you are bringing that, तो आपका पेपर जो है वो जैसे वो आईसीपी या कौन सी कॉन्फ्रेंस है गूगल जिसको ज्यादा कुछ अप्रिशिएट करती है, इसमें यदि आपका पेपर है तो यू आर डेफिनेटली गोइंग टू गेट अ जॉब इन गूगल रिसर्च टीम. जैसे आईसीवीआर करके कॉन्फ्रेंस है, मतलब वेन एवर गूगल आस्क फॉर सम जॉब रिक्वायरमेंट्स, जैसे कि एआई में या गूगल के एआई रिलेटेड एरियाज में दे आर लुकिंग फॉर द पीपल, तो उसमें एक ही पब्लिकेशन है तो मीन्स द पर्सन इज एक्सेप्टेड, बाकी कुछ नहीं देखते, because that is the conference which actually has a very high standard, that if you bring out some accuracy with your papers and if you contribute to them and if you are getting that sort of accuracy, it is accepted, means it is proven that your work is acceptable. But usually in case of student scenario, in our case, like हमारे पास कुछ graduate student रहते हैं, BE वाले जो ME वाले हैं, they try to bring out very high accuracy sometimes. So उस time पे क्या होता है कि it is for those constrained environment only, but it is not going to work for in terms of a universal way. हमारे पास जितना भी डेटा लिया है उसको हम ला सकते हैं 90, 92%, 93%, 95%. यदि 99% एक्यूरेसी आ जाती है तो इसका मतलब देयर इज अ क्वेश्चन मार्क. इट इज स्टिल नॉट पॉसिबल टू दैट सॉर्ट ऑफ bring that sort of accuracy. So in my personal opinion, it is 87 to 92%, more than 92%, it's also good. But people accept that without any question, that okay, it's fine to get that thing. जब कैनन से मैंने बात की थी, मेरा जो स्टूडेंट था उसमें, like he told me that Canon has actually got a project for surveillance camera, in that they wanted to classify the objects. So Canon started working with capturing the photographs. So they had a photographer teams spread across the world. They started taking pictures of different locations on the traffic signals, etc. And finally they created their own data set. And whenever they got that project, they told that we are going to give you maximum 92% of accuracy. So it will working most of the time with that sort of accuracy. That is what the conversation I had with one of the employee of that company. So it's like all up to the developer, the requirement, or the maybe the user or the customer who is looking for that sort of requirement. but 90 is standard. So 87 to 92 is, I should say 90 is it should reach to 90%. That is what my personal opinion is all about. What are your views about that? Do you have anything to tell about that thing? If you have something to
Yes, sir.
say.
Because during my research project, I got around 95%. So my guide immediately started doubting about the
Yeah, that is
credibility of
what I told you. That is what I told you,
this.
because it's like जब भी किसी के ज्यादा भी मार्क आते हैं उसी टाइप का है कि इतने सारे मार्क्स कैसे आ गए भाई. Anyway, but it is good to have 90% or more than 90% is always good. There is no
And
standard. Yeah.
yeah, and sometimes what happens is
Sir,
the
I
data
can.
that we have.
Yes, yes. Let us have an interactive one. So I would like to listen from you also.
Sometimes the data that we collect, sometimes it may be biased also. So
Yeah,
because
yeah.
of that, also we sometimes get a higher this
It's
accuracy.
always true. It's always true.
It
Even
depends on the data what we collect and the constraints that we apply on the collection of data. Is it,
yeah.
sir?
Yeah, true. Because see, मैंने जब पहली बार when I actually faced the problem, because I started learning all this 5 years back. At that time, I had collected those passport photographs of male and female, and I downloaded it from Google only because I was not much aware about those things, that we should have our own data set. But I started searching on the passport size photograph of Indian male and passport size photograph of Indian female. So what was the case that like कुछ photographs में तो passport है तो ठीक है चलो ऐसे ही photo आएगा, but usually if you take some pictures and crop them and get the faces of those people, many a times the face is little bit slanted or maybe tilted, or maybe there is something on the background. So all these background information also affects your result. यूजुअली पासपोर्ट फोटोग्राफ में क्या होता है, कोई स्टैंडर्ड व्हाइट या ब्लैक या कोई ग्रे बैकग्राउंड होता है, सो इट्स नॉट गोइंग टू अफेक्ट मच, या जो भी जितने भी डेटा है लाइक हैविंग अ सिमिलर बैकग्राउंड काइंड ऑफ अ थिंग. बट व्हेन यू टेक अ क्रॉप फोटो फ्रॉम अ ग्रुप फोटो, मे बी ऑन द बैकग्राउंड देयर इज अ सी, मे बी देयर इज बैकग्राउंड लाइक कुछ गार्डन है या देयर आर सम डिफरेंट बैकग्राउंड, सो ऑल दीज पिक्सेल्स having different color information will also affect your result. Because फेस का तो हो गया, चलो जो भी लैंडमार्क से द पर्सन हैज बीन आइडेंटिफाइड. But now the thing is that like other extra information is considered to be the useless information, I should say. It is not of our importance. Our main concept is to get the gender of the person from the photograph. So we should look for those things. But this sort of background information definitely affects the result. So आप कैसे bias data use कर रहे हो, या you have a variety of data. So initially एक पेपर था जो कोई इजरायली ने लिखा था. There was a concept like that Israeli was doing something. उसने ऐसा किया था कि initially they started working on the MATLAB kind of image processing concept. They started with measuring the distance between two eyes and measuring the distance from forehead to cheek, or maybe the nose and eyebrows, left right eyebrows, and distance between those eyebrows. And based on that, they came with a conclusion that in ladies or maybe in female or in male, this is the difference of distance between eyebrows and something like that. But that is not going to work for everyone, because if you look at that, that is not a universal criteria of detecting male and female from distance between eyebrows and cheeks and forehead, etc. So they started working on this sort of deep learning concept, and they collected huge amount of data of male and female photographs, and then finally they started working on that. So when I read that paper for the first time, I actually wrote an email to him that what you are exactly doing in this paper by which you are able to get this sort of result, and that is so much accurate. So he told that like we started this concept and finally this is what. So at that time I was so much impressed with that work, that how it is possible. But when I understood the concept of deep learning, it was so much interesting that even it's very difficult for us that how all these mathematical calculation in a model brings out all these results. And nowadays the technologies have developed so advanced that even you can visualize everything. In case of like the example which I gave you for the mosquitoes, I can visualize the complete cluster of all the data in a three-dimensional models. Even I can find out that which mosquito data is actually outlier. I can remove that for, because it is actually disturbing my model accuracy. So I can remove that data from the training also. That is also possible. So nowadays the technology has advanced like anything, and we are able to have a full control on the data. And as Madam has rightly said that whenever you are working on some sort of data, it is very much important that we need to do lots of data pre-processing first. Until and unless we have not done anything and blindly we have used the data to train the model, then it is definitely going to work bad in terms of accuracy. Why? Because if you do not look each and every data manually, it will definitely actually ruin your outcome or in terms of result or the accuracy. What happens exactly in terms of image data? It is very easy to visualize them. कि हम लोग image को एक बार scroll करके जाते देख रहे हैं, like see fine, if there is unknown image or unwanted image, we can definitely remove. But in case of numbers, what will happen? See, if I have taken a sensor data for accelerometer, AX, AY, and AZ are basically the three different acceleration data from X, Y, and Z direction. Now, what happens that maybe during the collection of the data in the Z direction, I might have different vibration or maybe thrust in my hand, and maybe some outlier data has actually recorded. So it is not possible to visualize them. So we need to apply some sort of statistical methods, and there are lots of techniques available by which you can find out some outlier data. We need to see the distribution of the data. We need to plot them using matplot libraries, and finally we'll be able to check, okay, these are some of the information or the data which is in the data set. I need to remove them at least to bring out a very good result. So statistics ये सब जो subject है वो like basically the subject to bring out what exactly you want. You can play with those data, you can play with the formulas and bring out what you are exactly looking for that. So it is also reverse in terms of like जो भी आप चाहते हैं वो ला भी सकते हैं और आप जो भी नहीं चाहते वो नहीं लाएंगे, ऐसा भी एक concept है इसमें. मतलब it is all about the data, how clean it is, how pre-processed it is, how much data you know very well. Because मैंने आपको एक सेंसर का डेटा सेट दे दिया, like it has lots of data for different gestures, but गलती से उसमें एक अलग gesture का data आ गया, तो आपको ये like you must be able to identify that particular thing, that it is not a data for that portion. Until and unless we don't plot them, we will not be able to identify that thing. Okay, so moving ahead to the next slide.
Hello?
This is again this, yes.
Sir, whether pre-filtering is also leading to biasing the data set?
Yeah, but sometimes it is also needed. Otherwise, what will happen, sir? Say for example, मैं आपको एक student की height का data दे रहा हूँ कि age starting from 0 to 70. जैसे ये कोई एक बच्चा है वो 0 to 70 की एज पे पहुंचता है, तो उसके पूरी लाइफ का एक लाइफ टाइम है, टाइमलाइन है, उस पे आपके एज का डेटा ले रहे हो. तो जितने भी डेटा हमारे पास आ रहा है, वी नो दैट up to 21 year of age, the height can increase and finally it can reach up to 7 feet or maybe 7.5 feet. पूरे वर्ल्ड में जो भी हाईएस्ट हाइट का है वो 7.5 जो उसके करीब है, मे बी 8, इट्स ओके. बट जैसे ही 30-35 की एज आ रही है और वहां पे भी कोई इंक्रीज हो रहा है हाइट में या डेटा में चेंज हो रहा है, सो वी नो दैट कोई आदमी की 40 साल के बाद तो हाइट बढ़ने वाली है नहीं, और कोई भी ऐसा है नहीं जिसकी 9 फीट से ज्यादा है. इफ देर इज समथिंग, इट इज एन एक्सेप्शनल वन. Definitely we can bring out or maybe we can keep it for one data or one data sample. But आपके पास कोई 1 करोड़ लोगों का डेटा है और उसमें 10 लाख लोगों की हाइट का डेटा है, उसमें 9 फीट दिखा रहा है, तो it means there is some problem with the data and we need to definitely filter them. So based on our perception, like a few months ago I had a very good session from chief data scientist of Reliance Jio, Dr. Shailesh Kumar. I think many of you will be aware of him. So he was talking about the perception of learning at the data. What he told exactly is that how we see the data, that is very important. आपके सामने यदि क्रिकेट का 3 स्टंप रखा है और आप यहाँ से देखेंगे तो आपको 3 ही दिखेगा, यहाँ से आप देखेंगे तो आपको एक ही स्टंप दिखेगा. So it is what how you look at the data, the perception about the data in terms of like how you project the data. आप यदि उसके पीछे एक टॉर्च लग के उसका एंगल अलग अलग चेंज करेंगे तो आपको उसका जो शेडो है वो ज्यादा भी मिलेगा, छोटा भी मिलेगा. So how the way you are applying different mathematical models, mathematical techniques on the data will give you a different result based on that. So it is all about unlimited opportunities and unlimited techniques or methods you can apply on the data. It is all about your perception, your requirement, your target you want to achieve. So I don't call it as a biasing, but it is basically our requirements, I should say. हम क्या लाना चाहते हैं, हम किस पे काम करना चाहते हैं, what is our target we want to bring. That is what the main concept is all about. So आप जो भी कर रहे हो डेटा के ऊपर, जो भी एनालिसिस कर रहे हो, जो भी उसके ऊपर अप्लाई कर रहे हो, उस हिसाब से आपको रिजल्ट मिल सकता है. बट इट इज ऑलवेज, आई शुड से, इट इज ऑल अबाउट लाइक नॉट using a word called bias, but I should say the scope of the research work, what we are actually targeting. हम जब भी पीएचडी करते हैं तो वी डिफाइन अ स्कोप ऑफ द वर्क, मींस हम इतने स्कोप में काम कर रहे हैं. लाइक मैंने जो डेटा कलेक्ट किया है, मे बी इट इज रिलेटेड टू दिस एज ग्रुप और दैट एज ग्रुप, और मे बी इस सेंसर का डेटा है उसमें भी मेरे पास लिमिटेशन है, यदि मैंने इंडियन कंटेंट के लिए टेम्परेचर डेटा कलेक्ट किया है तो मे बी द रेंज वुड बी समथिंग अराउंड -5 degree to 55 degree. That can be the normal temperature range in Indian continent, but if it goes to Antarctica then definitely it will change. So whether I'm biased or whether my scope of work is different, that matters a lot. That is what my personal understanding is all about in terms of data and biasing.
Sir, excuse me, sir.
Yes.
Hello. Sir, may I know the accuracy of ML and AI? What is the accuracy of ML and AI?
ML and AI difference.
Yeah. What is the accuracy range? May I know?
सर आप AI और ML का डिफरेंस पूछ रहे हैं या एक्यूरेसी की बात कर रहे हैं?
Not asking difference. What is the accuracy level of AI?
अच्छा नॉर्मल AI में कितनी एक्यूरेसी होती है?
Yeah.
Yeah, usually most of the system works around 90% of accuracy or little bit more than 90% of accuracy. It's not 99%. Not a single system has been found to be 99% accuracy till so far. Because even
Then why we have to go for deep learning? So it is giving more accuracy. Why we are going for another method?
it is not, sir, low accuracy, because deep learning is basically looking or digging more into the data in terms of specifically for image, audio, video data. We actually go to vision concept, and that is specifically related to deep learning concept. So deep learning is all about like looking at all the features and using all the weights of those parameters and features and finally playing with them and preparing a kind of a model which we try to bring out as much accurate as we can. That is what the main concept about, like bringing out a higher accuracy. 90 हम जैसे हम human है, like say just to understand the concept between like why this system are not that much accurate in terms of like is human, because we are not accurate. कोई भी ह्यूमन वर्ल्ड में ऐसा नहीं है कि लाइक वो इज हैविंग 100% नॉलेज, 100% एक्यूरेसी इन एवरी टास्क. इवन दो लाइक सचिन तेंदुलकर है, ही वाज हैविंग द बेस्ट बैटिंग स्किल्स, बट कभी कभी वो भी जीरो पे आउट हो जाता था. द रीजन वाज लाइक वी एज अ ह्यूमन आर नॉट एक्यूरेट इवन. सो हाउ वी कैन एक्सपेक्ट दैट द सिस्टम विल आल्सो बी एक्यूरेट, बट वी ट्राई टू ट्रांसपोज द इंटेलिजेंस लाइक एज वी हैव ह्यूमंस. हमारा जितना है उतना तो हम ट्रांसफर कर सकते हैं. दैट इज व्हाट द मेन कांसेप्ट इज ऑल अबाउट.
Okay. Thank you, sir. Thanks so much.
Sir, excuse me, sir.
Yes, please.
Even though deep learning is very correctly classified the images, what about the emotional intelligence of the humans, sir? Whether systems can imitate that?
That's a very interesting question. Actually, like, sir, emotional intelligence is also surrounded with lots of parameters. I mean, to say features basically. मैंने जब एक यूनेस्को दिल्ली में जो MGIP है, that's a UNESCO's category 1 institute. They actually look for or working basically for humanity part of the education system. So वहां पे हमने एक इमोशनल कोशेंट की हम जब बात करते हैं ना, EQ आप जो बोल रहे हैं, मतलब that is what you are talking about, EQ, emotional quotient of the person. So usually क्या था कि I was discussing with the director of UNESCO in Delhi in his office at that time. So I told him that like we evaluate the student based on the mark sheets. जब भी कोई स्टूडेंट का मार्क्स आता है तो उसमें हम देखते हैं कि हाँ ये अच्छा परफॉर्म कर रहा है, मार्क अच्छा है तो मतलब स्टूडेंट अच्छा है. But still, we have terrorists who are PhDs, we have terrorists who are engineers, we have terrorists who are doctors. So where the humanity factor comes into this picture? So we need to evaluate the student based on their emotional quotient. So how you can do that thing with AI or ML or maybe the deep learning concept? तो उसमें हम लोगों ने डिस्कस किया, काफी अच्छा किया कि जब हम लाइक केजी में थे, नर्सरी में थे, 1 2 3 स्टैंडर्ड में थे, उस टाइम पे हमारा जो स्कोर कार्ड आता था ना, उसमें सब कुछ लिखा होता था कि ये बच्चा मतलब सबके साथ मिलता जुलता है कि नहीं, हाउ सोशल ही इज, हाउ इनिशिएटिव और एंथुजियाज्म एंड एवरी पैरामीटर्स, कि वो किसी का साथ शेयर करता है या किसी को हेल्प करता है. देयर आर सम पैरामीटर्स, और उसके बेस पे हमको ग्रेड मिलता था, ए प्लस प्लस बी, ऐसा करके. When we come into the school, all these things are removed. Even we don't know. But while as a professor, you might have also observed that whenever you are taking a lecture, you can feel the emotions of all the students. यदि कोई student के घर पे कुछ हुआ है, या maybe he is having some problem with the friends, or he's not in a very good mood, but we never evaluate those things based on, because we are only evaluating based on the marks. On the education system, we have only marks. If he is getting a good mark, we are taking that student that he is a best one. बट विद द मार्कशीट ऑल्सो वी शुड हैव EQ टेबल कि चलो ये जितने भी लेक्चर अटेंड किए हैं, द इंटरेक्शन इन द कॉलेज, वी शुड हैव सम सॉर्ट ऑफ CCTV camera, which is running a machine learning model specifically for deep learning, that it actually measures the emotional quotient of that particular student. Like जो जितने भी स्टूडेंट है सभी का एक्सेल शीट में वो इमोशनल क्वोशंट का हर एक लेक्चर में उसका मार्क्स आना चाहिए. He was happy in the lecture, he was not happy, or maybe he was angry, he was not like attentive, and all these things. So what are the different factors? Because when you go deep into these areas, finally it comes to the cognitive sense of the student. Cognitive sense में क्या होता है कि जो भी यहाँ पे मैं लेक्चर ले रहा हूँ, so my cognitive sense is that okay 2:30 के बाद में मुझे ये मीटिंग है, या मुझे शाम को बाहर जाना है, या after 3 months I want to go to vacation, or there are lots of things maybe happening on the subconscious of my mind. So all these cognitive senses are also affecting my current performance. यदि मैसेज आ गया कि प्रिंसिपल सर ने इमीडिएटली इतना डेटा लेके बुलाया है, so maybe my lecture is also being affected because my cognitive sense is related to lots of things, like in terms of active working style, or maybe later future, or जो भी past में किया है, there are lots of things. So it's again a very deep area in terms of neuroscientific way that we need to integrate into our education system, by which we can make our human intelligence or our perception or the humanity part in the world a better way. कि मतलब एक student अच्छा है, उसको marks अच्छा आ रहा है, but he is not a kind of a very good human. How can you evaluate based on that? So we need some sort of deep learning or maybe machine learning concepts to identify with this. And this is again an unexplored research area where very few researchers have still work on. And for that we need some sort of standardization, and that is again, if you look at the United Nations Conference for Artificial Intelligence, that the biggest question comes in that there is no standardization still has been done. कि आप यदि कोई डेवलपर एक मॉडल बना दिया उसने कि चलो ये ह्यूमैनिटी का मॉडल है, so who is going to evaluate? Like in ITU we have standards कि आपका GSM का फ्रीक्वेंसी इतना होना चाहिए, आपका मोबाइल ऑपरेटर को इतनी फ्रीक्वेंसी पे काम करना चाहिए, या 160 कैरेक्टर का SMS होना चाहिए. These are all standards we have. GSM standard जो भी specification है, but there are no standards for AI still now. And every country, every company is working on that, and different people have different models, different architectures, different hardware. So there is no standardization all. आजकल Uber का या जो भी Tesla ने कार बनाया है, Google का जो autonomous vehicle है, they have made something. But who is going to control that? There is no rule even. Like if you look at the cyber laws in India, and if someone comes with an autonomous vehicle, there are no rules we have that who is going to be punished for that, whether the developer or the company or the person who is buying that car. So there are lots of things which is debatable still now in case of AI, that we need some sort of standardization and we need some sort of control. Otherwise what will happen, that if it is out of control, then as you know that everything has a two different aspects, kind of a positive and a negative way. So it's again a very lots of things which we can discuss, but I think I need to cover also because I only covered 23 slides. Anyway,
Thank you,
what
sir.
is the time, madam? I need to finish.
Sir, actually it is up to 2:30.
Okay. Let us keep it for the whole day, and lots of things to cover.
Yes.
Anyway, tell me, madam, what I need to do. Should I continue for a few
Sir,
minutes, or
we'll be very happy to hear you, sir.
Yes, sir.
I need to ask the organizers also?
Sir, how many slides are remaining for today's session?
It's not possible to cover all these things.
Yes, yes.
But
Sir, we
anyway,
can continue it in our day after tomorrow, the session which we are having.
I will do that. Okay, anyway, what I will do, instead of showing the slides and all these things, what I will do, I will try to demonstrate you a complete example. Like I think after the discussion that many of you are having a very good experience in AI, ML and DL. So that would be more interesting to you, that I will show some sensor data, and if I train them, and if I show a model, and if I deploy that on a hardware, and finally, if it is working live on the WebEx platform directly right now, it would be more interesting. So that we will do. Let me show you something which I'm going to discuss in the next part. So I will come to that part only, and later on. Okay. So this is the Arduino Nano BLE33 Sense model I'm going to use in the next session, on which I'm first of all collect the data using this same thing, because this has lots of sensors inbuilt into that. I will show you those sensors. Okay, so this is a very interesting board. Usually what happens, we need to connect lots of sensors with the Arduino board, but it has onboard sensors. So there is a sensor for color. So you can identify red, green and blue, or the combination of RGB. There is a sensor for brightness, so light intensity can also be measured. There is a proximity sensor. There is a gesture sensor, like if you are moving your hand from left to right, right to left, up, down, like it understands all these gestures. So inbuilt, there is a gesture sensor. There is a digital microphone, so you can do all the activities like what an Amazon Alexa is doing. You can ask the question, you can give different keywords to your AI system, which understands your keywords and everything. Motion detection, vibration, orientation sensor, like it's a 9-axis inertial motion unit basically. So it gives you acceleration in XYZ direction. It gives you the gyroscope value for XYZ direction. It also gives you the Earth's magnetic field in the north, east, south, and west direction. So even by moving the sensor in a different direction, you can identify that in which direction you are heading based on the AI system. There is a sensor for temperature, humidity, and pressure also. And there is a Bluetooth inbuilt into that. So these are the sensor out of which we will take only one sensor, which is known as an accelerometer sensor. कि जब भी हम कोई मोबाइल को like portrait or landscape करते हैं, there is an accelerometer sensor which is actually working to move your screen from portrait to landscape. And I will also show you how these the data look like when you collect them. See, these are some of the sensor data on the Arduino board, and I will use this sort of data. यहाँ पे मैंने कोई gesture किया है, तो it shows me a kind of a lavender signal. It looks similar to some sort of. So these are some of the things which actually the AI model understands, and these are the raw data whenever we collect them. आप में से किसी लोगों ने teachable machine use किया है Google में? Like anybody experience in the teachable machine? So I will take 5 minutes to show you, because I had something written in my today's session that there is some hands-on demo. I'm not able to do that because of the time constraint, but that will not take much time. I will take only 5 minutes to demonstrate. So let me share that screen of my Google, this one. मैडम इसमें स्क्रीन को स्टॉप कैसे करना है? अच्छा, ऊपर से आता है, ठीक है. स्टॉप शेयरिंग. I have not used WebEx much. So right now what I'm doing is that I'm showing you a very easy ready-made Google platform by which you can create any of the system. Hello. Okay. So now I'm sharing a very interesting one. Even you can show this to your even small kids also in the home, who will be able to use this teachable machine with google.com. It's a very interesting online platform to make
Sir,
any.
I just want to give instruction to the participants regarding just now we have talked on the phone.
Yes, please.
Friends, sir will continue for more half an hour. Will it be okay for you?
Yes, ma'am.
Okay, madam.
Yes.
It's okay.
Okay, ma'am.
Yes, ma'am.
Do they need any?
Yes, ma'am. Yes, ma'am.
Yes. Yes. Okay. Sir, please.
Okay.
Okay, ma'am.
Fine, ma'am.
Okay, so this is an online cloud-based platform of Google. It's a teachable machine, they call it as a. So what you can do is that without anything, without any source of data, without any algorithm, without any model, without any cloud, without any programming knowledge, you can create, but even you can generate the code also to deploy on some of the devices. So how it works, let me explain you. Are you able to see the screen like image project, audio project, post project, etc.?
Yes, sir.
Okay,
Yes, sir.
so what is the concept is all about that if I want to do a project based on the image classification, how I can start with? I do not have any data, but I want to generate the data. So based on that, once you click on the image project, you will be able to see that there is a new screen where you want to create a new image project, standard image model, and we want to select that. Okay, now this window has opened, in which you are able to see that there is a class 1, class 2, etc. You can add a class also here. So say for example, I am creating a AI model right now that I want to detect whether a person is wearing a mask or not, with mask or without mask. If you want to identify using a machine learning concept, how we can create that. I don't have anything right now with me. I will directly open the teachable machine with google.com. So here I will give a name called without mask. This is one of the class which I am creating right now. And I will switch on my web camera here. So it will, okay, I need to stop this camera from WebEx and then I will be able to use because it's a conflict of the camera. I will stop my video. Okay, so now on the screen, without mask, my video camera is getting my image live. Now I will click on hold to record. And what I will do to give a variety of data, I will move my face from in the different directions. So it will capture all the images all together. Okay, so I will click on hold to record. I am right now generating the data without mask. I want to identify a person without mask and with mask. I need to provide a data set. And so this is the first step to create a data set. So let us see that first. Hold to record. I will click on this and I will generate different images. And I will move my faces in the different direction also. Okay, so now you can see that there are 172 images have been sampled and they are available in my Google Teachable Machine platform. Okay, that's fine. Now I will give another name here, that with mask. Now what I need to do is that again I need to start the camera, but this time I need to wear the mask because I need to provide that sort of data. So I will wear the mask. I will hold to record, and similarly I will have different angles for recording those data. Okay, in the test we had 172 images. Right now, so as we had discussed that whenever you have an imbalance of data also, that will also affect the accuracy. So I should have equal images, but okay, there is not much difference. There is a difference of only 8 images. So 172 images are for without mask and there are 180 images for with mask. Now you can see that these are the two different classes of data. It's a kind of a supervised learning where I'm already telling the images with a label that these images are without mask, these images are with mask. And here you can see that these both the image data sets will go to the train model. So here Google has already prepared some sort of algorithm on the cloud platform itself, by which all these two different types of data will be given to training algorithm. So I click on training model right now. So it will start uploading all these image data to the Google Cloud server. It will start the training of data and it will directly generate a model which I can use without any problem. I can download that. I can use it in my Android application also. I can deploy it onto the Arduino also. I can deploy it on any of the website also where I want to identify whether the person is wearing a mask or not. Maybe we can put it in a kiosk also in front of some railway station or maybe the college entrance or something like that. So, and right now this is again a kind of a biased data because it is only meant for me, but it will work for others also definitely. But the thing is that we need to have variety of people. Like there are lots of age group of people, male, female, etc. So we can collect all this data. And again, it depends that at which different distance I have collected these information. So that is also a very important part. So right now training is going on and we'll see that how when it finishes, it will not take much time because this is on the back end of GPU cloud server. So now you can see that training has started. It is taking all the, and you can see that these are basically the 50, I think it is basically the epochs. So it is taking all these and it has basically trained the model right now. Okay. Now you can see that everything is running well. In this particular middle portion, training has already been done. The trained model is basically deployed in the screen right now, in which you can see my face. And if you see here, it shows that without mask, 100% accuracy. Now, if I wear the mask, or maybe if I move my face from this to this, it is again showing me the highest accuracy, 96%. Okay, now let me wear this. Now you can see with mask is again 100% accuracy. If I remove the mask, it is.
Sir, use handkerchief. Sir, use handkerchief, please.
Handkerchiefs.
Handkerchief.
Okay. With mask. I should keep my hand here. So now it is a little bit confused. So again, as you said, like you had the right question that the color of the mask also matters, because sometimes if somebody is using a skin color mask, then again accuracy will be affected if somebody is using a dark mask. So when we have variety of data I mean to say people with different mask type, different mask, different shape and size of the face, etc., different backgrounds also. Right now the background is also same in my case, because I'm sitting right now on my chair and the background is same in both the cases. So this background information also adds into the accuracy of the model, actually affects the accuracy of the model. So as we have variety of data, the more the model will going to work well in a nice way. I mean to say with a higher accuracy. So now this is okay. This is fine for a kind of a student who is learning something and want to do something quickly. But here there is an option that if you go to advanced part of this training model, here you can see there is an epoch of 50, batch size of 16, and learning rate is 0.01. As I was discussing with madam who asked me a question that how can we decide? So here, if you want to change the accuracy, if you want to see how it affects means कभी कभी क्या होता है कि लाइक हमने कोई एक चैप्टर को 10 बार पढ़ लिया, we know everything, we are so much accurate in terms of giving the answer. अब 100 बार पढ़ने के बाद हम उसको 1000 बार पढ़ेंगे, it's not going to affect the accuracy. So it is kind of a saturation of something. So here if you change the epoch, batch size or learning rate, and if your accuracy is not increasing right now, it means that it's not going to affect at all. But if you reduce these parameters and try to see, if you increase the epoch size, reduce the batch size, change the learning rate from 0.001 to 0.01, how this combination of the parameters affects, and maybe after trial and error you may get a very accurate model that works finer than the Google's existing model, which is considered as a taken as a default model. So this is one of the default parameter which Google has taken this. Now if you want to see that under the hood what happens exactly, here there are lots of things by which you will be able to understand the graphs and accuracy per epoch and number of parameters you want to see for your model. So it gives you loss at different epochs. So there is not much loss into this. So they also show you some technical parts based on that. Okay. And one more thing is that whenever you want to deploy this, how to do that. Okay, now we have created a model. We want to load it on a ESP32 CAM or maybe an Android application. So there is an option here to export this model. So when we click on that, it gives you everything in terms of ready-made code which is being generated automatically. So here, if you want to use JavaScript, you can directly use this JavaScript, put it into a web page. Whenever somebody will open that web page, your model will get loaded automatically in the browser itself. So initially, in the first few seconds, it will take some time to load the model. But finally, the model.json file will get loaded. And if you have created a website of your college or a university where if somebody is coming like into the entrance, and if somebody is in front of the camera or the web camera, the website will identify that, okay, this student or this person was without mask whenever he passed through that camera. If you want to use some P5 related JavaScript concept, that is again different platform by which you can use. This is again a code which is available. If you want to use it for TensorFlow, and in case of normal Python programming, you need to use Keras model. At that time, you can use Keras ready-made code which is generated here. You can copy that and you can post it over the code which you have written for Python. You want to save the model or the download the model, that is also fine. If you want to create a mobile application, you need a kind of a quantized model. Quantize is basically a kind of a zip format of the model, because usually what happens whenever we create such model on the Google's teachable machine, they are in little bit higher size, maybe 70 MB or 100 MB. But when you quantize, it's a kind of a compression of the model. So here it is code snippet for Android and Coral. Coral is a development board which is prepared or developed by the Google itself. So it is similar to Raspberry Pi, but it has a TPU on that instead of GPU like NVIDIA Jetson Nano has. It has a TPU on that. So it's a tensor processing unit, I meant to say, not the graphical processing unit, because Google has developed TensorFlow technology, so they call it as a TPU. So here there is again a steps, different steps are given that if you want to create a mobile app by which you want to use this model for identification of with mask or without mask, you need to simply change the model location, model with replace with your model, and that ready-made mobile application, the code is already given on the Google TF Lite Android Studio example. Change the model and it will work. You need a quantized model, it is again available. You need an edge TPU model for Coral, it is available. So again, there is a procedure which is given for how you can install on your Google Coral board, and you can run with a embedded kind of a embedded system, or maybe edge computing kind of a device. So these are three different options. And even if you want to see the code, everything is here. Like go to tensorflow.js, the complete code is provided here, the how the prediction is done, how the maximum prediction you are getting in a loop, and etc. So it's a kind of a JavaScript basically. Even there is a complete guideline provided that FAQ, who can use my model. Even you can directly paste the link of that model into any of the website. You can even share on WhatsApp. आप किसी को भी ये WhatsApp में link share कर दो. Whenever the person will open that link, it will ask for the camera access of that mobile phone, and the message will appear like with mask or without mask. So the porting of the model on different platform is also very easy. So that is possible. So this is about something related to image. But what we want to do, there are other options also. You can add a new class also here. So maybe we can add something different, that handkerchief mask, something like that. You can create a data with this also, and then even you can identify whether it is a normal mask or a handkerchief mask, something like that. So it's all about your creativity. You can add a number of images and different classes, so it will identify. Now again, what will happen, that more number of classes you have, it also affects the accuracy sometimes, because when you have variety of data, it becomes very difficult to process them to train a model. But again, how you use it, how you train the parameters, all these epoch size, batch size, learning rate, into the boot, etc. Okay, coming back to the home page again.
Sir, assigning more number of data, whether there is any chance of being confusion, just like real life
Yeah,
applications?
what happens, sir, exactly is that, like, say, when you are talking about a binary classification kind of a thing, like 0 and 1, or maybe you want to have with mask or without mask, that is very easy. You will get more accuracy. But when you add something to that, as I said, like handkerchief mask or something like that, so maybe I think it's not a kind of a confusion, but definitely the accuracy will be affected. But you can bring as much as more accuracy by providing or changing the hyperparameters in a decent way, by which you can get the as much as higher accuracy you can. So that is what the concept is on. But it is not like that if you have more number of classes, then it will be a confusion. Okay, so second is the audio project. Audio project is also very interesting, but I think audio project will not work, because right now I'm using this microphone and this will not allow me to use the microphone of my web camera. But anyway, I will simply discuss this. So in case of any audio related project, you need a background noise. That is very, very important aspects of audio related project for machine learning. Why? Because we live in an environment where there is always some sort of ambient noise. And if you do not have any ambient noise into your model, then it will not be able to identify that what is happening right now. Say, for example, I'm playing a guitar, I'm playing a tabla, I'm playing a sitar. I have recorded all these three different sounds and I want to classify them using an audio project. But what will happen whenever nothing is being played? There is no sound of guitar, no sound of tabla, no sound of sitar. There is something which is called as an ambient noise. So I need to record some ambient noise also, so that whenever nothing is being played, it will show you that it is a ambient noise or background noise. Right now, nothing is being detected. So initially we need to store it in terms of audio samples for 20 minimum samples, and then we can classify as something like we can create here as a guitar sound or maybe some song, or maybe even you can use it for classification of different person's voice. Maybe in a family, like we are 4 people and we want to classify whether it is able to classify the voice of a person, that who is that person is speaking all about. So you can give the name like Kiran, Preeti, etc., and you can give the names, and finally whenever somebody is speaking, it will be able to identify those things. Okay, it allows me to record this sound. So I will record this 20-second samples. Okay, it has recorded 20 seconds of background noise, and these are all the, as we discussed it, these are all basically the conversion of background noise into a spectrogram. If you want to see that, this is a single sample out of 20 seconds of sample, second sample, third sample, even you can play them also, and you can see them, means you can listen them. This is basically a background noise. So it's all recorded. Now let us go to some another label. I need to, मुझे कुछ आवाज करनी पड़ेगी उसमें. I'm giving something like clapping. I'm not clapping, but I'm generating some sound. Record to sound. Let us take this much of data. It should work. Train the model. Okay, it asks for, I need to take more data. It's not sufficient. I started training now. So I want to classify between a normal background noise and some clapping kind of a sound. Usually, as a developer, what we do, we actually collect the data set for various different types of data set. Maybe it's image data or audio data, or maybe a kind of a different data related to pose estimation or something like that. Then we provide this data for training. We prepare the architecture of the model. We prepare the training algorithm. We get the trained model. We use that trained model for already used data as well as some sort of testing data. So usually whenever we have enough data for training and testing, we divide them into 60-40 as a ratio, 60% for training and 40% for training. And sometimes the testing data is also divided into two different parts for validating those models. And usually we do all this by writing a code. Here we are just taking a demonstration of the cloud platform, and it's a kind of a user interface directly, so anyone can use it as a beginner or just to understand what exactly happens whenever we are creating a machine learning model. It's taking some time to train because all these samples will be uploaded in the background. But in the screen itself, on the screen itself, it converts all the audio samples into the spectrogram. So whatever we are looking at the screen are basically the spectrograms of all the 2 seconds of samples which were recorded previously for clapping as well as for background noise. So now, see, sometimes what happens that it all depends on the creativity of a person. My brother is a pediatrician, and I was talking to him that whether you are able to identify for which reason a infant is crying, basically, because they have neonatal ward, and in the neonatal ward there are lots of small infants are being kept. So they have different sounds for crying, and the doctor knows well that because of this reason, this is the sound, or maybe like the infant is hungry, or maybe he's having pain in the stomach, or maybe he's irritated, or maybe there is much colder outside, or maybe hot outside, or something like that. So they know everything. So if we have that sort of audio data of different infant sounds, then we can even classify them in a normal. Usually, what happens that whenever you become a parent for the first time, even it is the scenario for everyone that even you don't know for what reason the child is crying, so we'll go to a rush to the doctor, but you can make an AI device which is a wearable one. उस पे दिखाएगा कि हाँ भाई ये इसको खाना खाना है, या उसको इरिटेशन हो रहा है, या उसको स्टमक में कुछ प्रॉब्लम है. That can hint you something like that. So similarly, how creative you are, you can do this thing. So now, right now I'm speaking, so it's not able to classify well, but I will stop speaking and we'll see that background noise will have 100% accuracy, and when I will do some sort of clapping sound, it should increase the accuracy for clapping. Okay, so it works well with a very smaller amount of data also. And again, similar way, you can export the model and you can check everything. And this is basically the window which you are seeing right now, because the audio is continuously being captured by the microphone, which is being scrolled here. And there is a window here. In that particular window, the sample is taken and the classification is done. So in the beginning, I talked about the Mosquitoes wing beat sounds. So that wing beat is very small window. And if you are not able to properly set the window size, it's very difficult to get the accuracy into that. So here you can change the parameter also, like overlapping factor, and you can change the window size here. It is written what exactly it is. So you can read about all these parameters. So this is again a concept of having an online kind of a teachable machine. This is for pose estimation. See, when I open that pose estimation model, it actually observes the pose of a person, and you can create your own pose also and use it for various activities. People have started making the robots which can identify whether the video which is being played on the TV screen is a kind of a sporting activity, it is being a football activity, or maybe cricket, or maybe a table tennis or something like that. So every data has been fed into that and pose estimation has been done. So even a robot can identify what is being played on the TV itself. So that is what the main concept of identifying a PoseNet model. How to record. See, right now, if I do something like this, it will identify my pose that I'm doing like this. If I stand up and will, actually, I need to go away from this. So this is my pose. I move my hands like this, it will draw the lines. So I need to record my pose, and based on that, I will be able to classify them. It identifies some landmarks on my face, 2 eyes, 2 ears. Whatever I do, it will identify the landmarks on my face, and some landmarks on my shoulder here exactly. So it's like a skeleton structure what is being identified by the camera. Why it is able to identify? Because it has already downloaded the PoseNet model. PoseNet model is already prepared, and PoseNet model actually gives your pose. So now you want to create your own different pose. whether you are doing garba, whether you are doing belly dance, or whether you are doing some sort of jumping the ropes, etc., you will be able to identify those things. And based on this, China has actually developed a very good surveillance system that they are able to identify the pickpocketers before the pickpocketer will do that activity. So they have collected lots of data from the surveillance camera and they have trained using the PostNet model कि जब भी कोई ये लोग जेब काटने वाला है उसकी एक्टिविटी क्या होती है. So based on that, they immediately identify that within few 10 seconds or 20 seconds, this is going to do this mischief, and they are able to track them. And all these cameras are connected through internet work. Wherever the person will move, the next police station or points will be identified that the person like this is moving, and you need to catch them because he is a pickpocketer, something like that. So even they are able to identify that on a pedestrian like फुटपाथ पे जो जा रहा है उसको वो कहाँ से कैसे टर्न करेगा. They are also able to predict those things. I mean to say there is no logic behind that. There is no logic behind. देखिए सबको अपना काम रहता है, उस हिसाब से ही वो स्ट्रीट में लेफ्ट या राइट जाने वाला है. But based on the data which they have collected, they are 90% accurate that the person who is coming on this way is going to turn left or turn right. So they are in that much advanced that they are able to find out those things. So I think this is enough for today. Maybe next time we will try to see the practical demonstration. This is not a practical demonstration. This is a ready-made platform which I'm trying to show you. Madam, is it okay to keep it up to here?
Yes, sir. Friends, if you have any query, you can discuss. किसी को कुछ क्वेश्चन पूछना है तो आप पूछ सकते हैं.
Ma'am,
Yes, ma'am.
ma'am, is this teachable machine is used for identification of object?
Yes. You need to train that. आप उसको train करो. That will work. You show that banana, apple, and orange and everything, and give label like that, and use that model into your mobile application. It will work definitely with more than 90% of accuracy, because it is already a kind of an Inception model which Google is using in the background.
Okay, sir.
It will work for everything. Whatever you say, it will work for everything because you are creating your own data set. If you show fan, if you show mouse, label them like that and provide a variety of data in terms of different fans, different mouse types, etc. Wired mouse, without wire, wireless mouse. It will work definitely. It will work for different sounds also.
Sir, can we merge two items? Means, for example, image and sound.
Combination is not possible right now in this. Combination is not possible. But what you can do, sir, is that if you are transferring this to a mobile application or maybe a Raspberry Pi or any embedded system, what you can do is that you can load two different models in the Python code or maybe the Android Studio, where whenever there is an audio data, it should pass through that audio model, and when there is an image related data, it should pass through that image model. So your system is having two AI models running inside that, and based on the provided input data, it will give you the output. Or else what you can do is that you can use the video. That's a combination of image basically. So video is nothing but a collection of various frames all together, and based on that you can classify them. Even people have started working on the lip reading kind of a thing, that even you're not speaking anything, but just by looking at the lip movement, it is able to generate some text. And there is a very good interesting area people have started working on those areas. It is all about like diarization of the audio in terms of this sort of online meetings. What happens exactly that right now I can see various names like Dr. K. Srinivasan, Kisan Desai, Kishore, etc. So whenever all these audience or maybe all the participants are speaking, definitely the Zoom platform or a Meet platform or WebEx platform is able to translate them into text. But it is also able to identify who is speaking right now. And based on that, they have actually created an AI model into Zoom also. They are using that. So speaker diarization is one of the concept where you are able to identify, classify who is speaking, even the converting those text into those voice into text also, and creating a data set or maybe creating a transcript based on that. That is one of the area one of the recent area. Yes, there is a question from Dr. Dethe. Yes, please.
Excuse me, sir.
Yes, sir.
So I'm a faculty of electronic science, and I find it very interesting when like AI and ML comes, and I want to pursue my PhD in this term, in this line. So is it possible that to be very frank, I don't have any background as such that like I've never learned AI and ML, but I find it very interesting whenever it comes, whenever I find it in refresher courses and other workshops. So is it possible for me to pursue PhD in this line, sir?
Definitely, sir. You can start with, and this is one of the interesting area right now because it's a combination of all the different domains. Because you are already having an electronics background. Having an electronics background, we are already having some sort of programming skills also. So you need only have a Python skill and the electronics background. Finally, you need to define the problem statement, find out the research gap, what people have done so far in a particular area in which you are targeting. मैं आपको सिंपल क्वेश्चन पूछता हूँ लाइक मोस्ट ऑफ द टाइम व्हाट वी हैव सीन दैट यूजिंग द कैमरा यू आर एबल टू आइडेंटिफाई द ऑब्जेक्ट्स मतलब हम जो देखते हैं उससे तो हमको मालूम चल जाता है मतलब कैमरा से कि ये एप्पल है या बनाना है या टेबल है चेयर है कार है व्हाटएवर इज दैट वी आर एबल टू आइडेंटिफाई दैट बट इज इट पॉसिबल टू आइडेंटिफाई द ऑब्जेक्ट विदाउट कैमरा
Without camera, sir.
yes
M-
is it possible to identify
might be some like using some sensors which can
sensors
define the text.
any other sensors you can use but you need not have to use the camera without camera identify that what object is in front of you that is one of the area where people have started working and there are lots of success into those things also because we have an kind of an ultrasonic sensor we have infrared sensor we have color sensors so based on all these collected information say for example I have an RGB sensor. So whenever the RGB sensor is collecting something, based on the information which is being displayed in front of the RGB sensor, I should not say displayed, but kept in front of the RGB sensor, it will have combination of RGB or maybe the combination of all these three color values. Say if I show a mask like this, so it's having a red or maybe maroon color, black color, and some sort of other maybe white spots. So RGB sensor will give me the combination of all these different colors at some different locations on the pixel. So I will be getting those values. But now if I have an infrared sensor, or maybe I have a temperature sensor, or maybe a thermal temperature sensor, which we use normally in case of like all these corona gun, the thermal guns, scanning guns, etc. We will also be able to identify the temperature of the object also. We'll be able to identify the color also. If we send some signals and if it is absorbed in terms of ultrasonic way, then we will also be able to identify the object in a different category. So maybe without camera also, we will be able to identify some objects. And if you are able to do something in those areas, we will also be able to explore it further or maybe to scale up for various objects. Or maybe we can target some application, maybe some military application or maybe some healthcare application. We'll be able to do that also. So we need to see that what is next to what is existing right now. I think you must be knowing Dr. Ramesh Raskar. He's a professor of MIT Media Lab, and he's also from Nasik. I suggest all of you to look out that lecture on the YouTube. What is next? That how innovation happens exactly. Usually, we do not think about what is next, and that is what the main concept we need to think for research. Say everything is existing right now, but now what is next? How we can replace this technology completely? So, if you want to replace the camera where it is used for object detection, if you want to replace with a normal sensor, is it possible? Yes, it is possible, but we need to explore those areas in terms of collecting the basic information, then how we can integrate with the various sensors, take those data, and if you are able to at least classify 5 different objects, maybe human, maybe a wooden image, a wooden object, or maybe a steel object, then definitely it's a success in those directions because people have started working on measuring the heartbeats just by Wi-Fi hotspots. If you look at one of the paper which is available on the Media Lab of MIT, that MIT researchers have done something, and based on that, they are able to measure the heartbeats of the person sitting in the next room without any sensor. It is always a kind of a non-invasive kind of a technique. And just by having those Wi-Fi routers in the college, they are measuring the heartbeats exactly with more than 95% of accuracy. And after that, they also were able to they were successful to identify the emotion of that person. that if you do some sort of facial expression, your heartbeat and ECG pattern have some changes, and they have also identified those things, and they are able to display everything. Like दूसरे room में 3 लोगों को खड़ा किया है, you'll be able to see the heartbeats of all these 3 different person, and whenever they smile, there is a smiley here based on the heartbeats only. So this is one of the interesting paper. It's not a very new concept or a new paper published. It was published 5 years ago or maybe 6 years ago. But these are some of the unknown areas, unidentified areas, unexplored areas where we can start working. And definitely, Sir has suggested that you can definitely do PhD. It's all about our interest, creativity, and how much resources we have, because resources are always a limitation in our cases, because we do not have that sort of state-of-the-art equipments by which we can measure such sort of signals and reflections and number of things all together. So you can apply for some DST grants also and get some equipments for that. Anyway.
Thank you, sir. Thank you.
Any more question? So I think, sir, there are no questions. So on behalf of all the participants, I extend my thanks to you, Dr. Kiran Trivedi, sir. And we are having one more session on day after tomorrow. So we will continue with the same topic and some advanced part of it. Thank you so much, sir, for today's session. Wonderful.
Thank you, all of you. It was a really interactive session, and that made my task a little bit simpler because interaction is always a kind of a thing where we exchange the information, and even I also learn from you.
Yes.
So thank you so much, all of you, and we'll see you again in the next session.
Okay.
Thanks.
Thank you.
Nice.
Thank you, sir. Nice. Good day, sir.
Good day, sir.
Thank you. Thank you, sir.
Thank you so much.
Thank you so much, sir.
Thank you, sir.
Thank you, sir.
Friends,
Thank you, sir.
yeah.
Thank you, sir.
Yeah.
So friends, this is for our first day. We will stop here. And now you can take a break of some 1 hour and more. Then you can proceed with our today's quizzes and assignments. That task you have to complete till tonight 9 o'clock. आज के लिए आपको एक क्विज और रिपोर्ट सबमिशन करना है. रिपोर्ट जो भी लेक्चर आपका हुआ है उसके ऊपर आपको ब्रीफ एब्स्ट्रैक्ट लिखना है, and that abstract you have to submit as your report. If anybody has any doubt related to quizzes and assignment, you can ask. Otherwise, we will end our meeting here. किसी को कुछ पूछना है?
Hello, ma'am.
Yes.
Madam, can we get the recorded video of this
Yes.
lecture?
Yes.
Because
Sure.
there was no sound in the middle, so I was not able to get it.
Yes, ma'am.
So,
Sure.
so when it will be available, ma'am?
After half an hour.
Okay. Thank you. Thanks a lot, ma'am. Okay, ma'am.
Ma'am,
So,
can you share the slide of
sir, PPT तो सर ने मुझे से शेयर नहीं किया है, but in the video all the slides are there.
Okay.
Yes. मैं सर से अगर पूछती हूँ, अगर वो देते हैं तो I will share that PPT also.
पूरा टोटल 103 जो भी स्लाइड है वो अवेलेबल नहीं है.
जी सर, I will ask him, and if he send to me, I'll share in our WhatsApp group or in our Moodle site. Okay. So thank you all of you.
Ma'am.
जी.
Just a minute, ma'am. Ma'am, assignment should be submitted in the form of handwritten or typed matter.
Sir, your voice is breaking.
Ma'am, assignment be submitted. Am I right?
Sir, assignment. There is report
Madam, are you hearing
submission.
us?
There is report submission, sir.
Yeah. It is in the.
You have to submit report till.
It is in the typed form or handwritten form?
Sir, both will be accepted either in a typed form or in the handwritten form. Whatever is possible for you.
Thank you, ma'am.
Okay. So.
Thank you, ma'am.
All the best. आप अपने क्विज अभी ब्रेक ले लीजिए and then you can proceed with our pre-recorded videos that I have shared already in our Moodle site. और आज अपना एक ही क्विज है. सर का जो लेक्चर हुआ है अभी उसके ऊपर क्विज आज नहीं है क्योंकि सर ने क्वेश्चंस अभी तक नहीं दिए हैं. आज सिर्फ आपको वो जो प्री रिकॉर्डेड वीडियो है उसी के ऊपर क्विज है एंड देयर इज वन रिपोर्ट सबमिशन. इतना ही टास्क आपको आज करना है. ओके, सो सी यू टुमारो. कल का अपना टाइमिंग क्या रहेगा? Tomorrow's time.
7 o'clock.
7 o'clock.
Yes. Morning 7 a.m. yoga session. Yes, say 7 a.m. yoga session will be there. I will send the link in the evening for tomorrow's session. Okay. Okay. Thank you. Good day, all of you.
Thank you.
Yeah.
Thank you.
See you tomorrow.
Thanks a lot, ma'am.